start the Microsoft Azure virtual event this morning, and we have our speakers who are ready, especially Thomas. The first speaker is ready here, but before we proceed to give him the stand, I would like Abu to introduce the event properly. So Abu, over to you.
Hi, good morning. Can you come online? I want to see everybody on the video, please. Hi, Thomas.
Morning.
Hey, Thomas, Thomas, are you online?
Yes, I'm here. Can you hear me?
Oh, yeah. Can you come online, please? The video. Oh, yeah. Yeah. Welcome to Ghana.
Thank you very much for having me. It's a great honor to join that user group and present here, even though it's just virtual. But I think that gives me the opportunity to do this, so that's great.
Yes, we are happy to have you here. Everybody's happy here. My colleagues say hi to Thomas, please. Hi, Thomas.
Hi, Thomas. Welcome to Ghana virtually.
Thank you very much.
Okay, so I've saved some coffee that you can join.
So let's take the together mode picture. Thomas, we are taking together mode picture.
Okay.
Please come online if you are there to take together mode picture. Okay. Are you good? Yeah. All right. So Thomas is going to speak about Azure App, right?
Yes. I'm going to speak about Azure Arc and how you can manage your servers in a hybrid environment.
Oh, that's great. We really love the topic.
Perfect.
We are going gradually in the cloud, so we do hybrid mode. We love the hybrid.
Awesome. Now, then I have a couple of great things to show, definitely. Okay, should I start? Is that?
Yes, if you are ready, we are ready.
Okay, perfect. Then let me share my screen here.
Yeah, we are going to record the session.
Perfect. Where's my back? And in the meantime, I will need to turn this off. So, okay, thank you very much. Again, great pleasure to be here today to speak to you. My name is Thomas Maurer. I'm a cloud advocate working at Microsoft. I often get asked, what does a cloud advocate do? What's your job? And it's kind of like hard to tell because everyone is a little bit different when it comes to that. But in a high level, what we actually do is we are creating content and delivering content. These can be documentation, Microsoft Learn modules, blogs, presentations, like this one here, for example. And then we also do a lot of another part, which is not that visible in a way that a lot of people don't see what we do there. But we are collecting feedback from our customers and communities to know, to really like understand what is working, what is not working, how can we improve our products and services. And so we are directly part of the Azure engineering team at Microsoft. And again, that makes it very easy for us to speak to the different Azure feature teams. So if you have any feedback or anything you want to share, reach out to me or my team. You can find us. You can see here the contact details. You can find it on the website or on Twitter and so on. So definitely happy if you reach out with some feedback for us and what we can do better. So today, we're going to talk about hybrid management, especially about, I focus on hybrid server management, meaning you can manage your Windows and Linux servers running in your own data center or office or wherever you have them running. But it's not limited to that. I will also talk a bit about hybrid management in general. It's also about, like, for example, how you can manage your Kubernetes clusters, your Azure Stack HCI, and much, much more. So we will definitely talk about that. But I will make the example because with servers, because that is one like everyone really understands. So before by the way, I promise. So if you have any questions, please feel free to write them in the chat. I will answer them at the end of my session. I will only have time because I want to go through so you don't miss anything, and I don't want to make too long. So I will feel free to ask your questions, but I will have a look at it at the end. Also, I promise that I have a lot of demos. So I will go through a lot of, like, I show you most of the stuff in the Azure portal. So I have only a couple of slides at the beginning and at the end, which I want to show you. But trust me, there will be a lot of demo in this presentation. So before we actually talk about this, I quickly want to give you a little bit of information why we are actually doing this. Why did we create Azure Arc, and why did we create that hybrid management? So what we did is we had a look at how to do our customers, what are the challenges our customers have. And one thing we realized is that their environments are getting increasingly complex, right? They need to do more with less all the time. And so we had a look, why is that happening? And we found three main pillars, if you will. I mean, there's definitely more, but like we found like three main pillars why they are getting more complex. So the first one is, if you're an IT admin or a developer or in IT in general, working IT for a company, you usually manage tens or hundreds or even thousands of applications. And some of them are written in very modern languages like .NET Core, based on PaaS services, serverless, containers, and much, much more. But we also have some traditional applications, right? Probably the majority is like running in virtual machines or even on physical servers. And so IT needs to take care and manage all of that. At the same time, we also see a high demand, like in terms of infrastructure, right? So you have different infrastructures. Companies are running their services and servers in data centers, at service providers, in their branch offices, factories, retail stores, basically all over the place. And IT needs to manage these as well. And then another point we can see is that some companies are doing multi-cloud, right? And this can have multiple reasons, like especially like companies who decided, for example, to go with Microsoft Azure, which, by the way, is a great choice. They still probably have other cloud providers because they started using them before, like a department, for example, they already used another cloud provider before, and they're not just going to migrate everything over to Azure, right? Or some companies, they decide, okay, that's our strategy. We want to have multiple cloud providers, right? That can also be a part. However, that doesn't make it easier for IT to manage that, right? You know that even one cloud provider like Azure can already be a complex thing to have knowledge about and manage it. But IT needs actually to take advantage of all of that. So we also want to address that if companies have multiple cloud providers. And that is where hybrid comes in. And I want to show you that slide. That is actually a picture I took at Microsoft Ignite in 2019 in Orlando. This was the second keynote after Satya Nadella. And on stage, there was Jason Sanders. Jason Sanders is the engineering lead directly under Scott Guthrie in Azure and in Cloud and AI. And he does basically all the Azure engineering teams of the Azure services are underneath him. So he basically had the second keynote, and he was talking a lot about hybrid. And I want to highlight one thing he said. Like, there was one quote, and he said, "We understand and we believe that hybrid is an end state for our customers, and not just an in-between state until everything is moving to the cloud." And I think that is very important, because now this sets the foundation that we build everything, and we understand that not everyone can use the cloud with everything, right? There are reasons why companies want to use services on premises, or they have to use them on premises. Can be bad network connectivity, right? Could be like that there's no connectivity for some reason at all. There could be that they have data sovereignty reasons where they need to store data within their country, and they're not allowed to, for example, put it away. And so we see customers doing both. We see customers doing cloud. We do it at the same time. They need their on-premises or multi-cloud environments. And that is what we want to address. Another part is, you can see on that slide, we have a big set of hybrid services, right? We not just have one product or one solution when it comes to hybrid. We understand that hybrid for everyone is a little bit different, and we want to offer the right tools to our customers, so whatever they need, we can actually help them. And so we have our Azure Stack portfolio, which is not just a single product anymore, right? It's a family of products or portfolio of products. There's someone unmuted. So we have this family of products with Azure Stack. Hello. So we have this family of products with the Azure Stack Hub, the Azure Stack HCI, Azure Stack Edge, and all these some different profiles. We also talk about IoT, for example. I'm not going to cover that too much in this session, because again, we could speak for weeks about IoT and what our solutions are there. And then we have obviously announced Azure Arc, and this is the one thing I want to talk about today and explain to you what it is and show you a little bit about how it works. However, what a lot of people also don't know is that Azure was actually built to be hybrid, right? It was built to have like hybrid from the ground up. So we already have a lot of different services when it comes to like management services, like update management, security and identity. Think about Azure AD. When it comes to data services with our SQL Server, when it comes to DevOps and tooling, a lot of these things were already designed to be hybrid. We just did a very poor job in actually telling people that this exists, right? And so people were not even aware that they could also use Azure for their on-premises environment. So what does that mean? So this is a quick overview, and now I don't want to spend too much time on the slides, because I really want to present here some demos. Again, let's start on the right side here. This is again a very high level thing of our hybrid offering. So on the bottom right, you can see we have our IoT offering. Again, could speak probably days and weeks about it. Don't have time today to speak too much about it, but if you're interested in IoT, that's definitely a great place to start. Then we have our Azure Stack portfolio. Again, this is all bringing this cloud-inspired infrastructure into your data center or into your office, where you actually need to run servers and cloud native applications and much more. And then on the left side, you can see that's like the first part of Azure Arc, where we actually want to bring Azure services to any infrastructure. So that means, for example, our customers told us that they love Azure SQL, right? They like Azure SQL, they like how it works in Azure. However, some of our customers told us, hey, we cannot use it like for everything, right? We have some stuff which needs to be in our data center or in our office. So we need our services. We want to use it here. So this is one thing where Azure Arc comes in, is actually to bring these Azure services and make it available wherever you need them, right? It doesn't matter if it runs in your own data center, on a physical server, on a virtual machine, on VMware, on Hyper-V, or even at other cloud providers. That is one part. And then the other thing is the line in the middle. This is also a big part of Azure Arc, right? We talked about the challenges some of our customers have when it comes to managing all these applications, servers, Kubernetes clusters, multi-cloud environments. So we want to provide them with a single control plane. So we want to take like the things you can do with Azure, we want to enable them to actually use these things to manage these resources with like for resources which are outside of Azure. So when I speak about the single control plane, what I'm meaning with this. So with that, I'm meaning you can use Azure to manage your environments running on premises, in multi-cloud environments, or at the edge. And so when we speak about that, what does that mean? That means organizing and govern resources at scale. So you get that single control plane to have a view over all your systems. Take advantage of the cloud developer practices for your on-premises environment. So bringing like DevOps to your on-premise environment, bringing all the solutions from the cloud to that. And then implementing obviously Azure security. So you can take advantage of the Azure security services, but implement them and take advantage of them in your own data center. So instead of talking about this now for hours, I'm just going to show it to you. So let me quickly switch here to my demo. So I'm here in the Azure portal. And here you can see I'm on the all resources page. This is actually where you can see all your Azure resources, right? And then scroll down, you can see I have a lot of things deployed. And what you can see here is that everything in Azure is an object. Everything is a resource. So here, for example, we have a virtual machine, right? So I zoom in here, we have a virtual machine here. But you can also see that we have other things like disks, network interfaces, even public IP addresses are resources, right? Everything is nicely organized with that. Everything has a type. Everything is part of a resource group. Everything is somewhere connected to a location. And then also part of an Azure subscription. Again, this is nothing, this is exactly how Azure works. We can also use tags to manage these resources in a better way. So we can, for example, assign cost center, location, like all the information we want to a resource. Now, customers told us, hey, this is great to manage our Azure resources. We want to have this to manage our resources which are outside of Azure. And so I'm going to show you this. Now with Azure Arc, we can not just show you things which are in Azure, but also things which are outside of Azure. So what I'm going to do here is I'm quickly going to show that only want to have, if it's loading, I only want to show you that to make it a little bit simpler, I limit here to virtual machines. So I only want to see my Azure virtual machines, and I want to see my servers, which I already have added using Azure Arc. So these are servers which are running in my own data center or underneath my desk, to be honest, which for demonstration purposes, right? So these are not Azure services. These are servers running outside of Azure. So I'm going to apply, and now I'm filtering for this. So you can now see what I can see here is I can now see Azure VMs and servers running outside of Azure side by side, right? So let me quickly see there's something wrong. I just want to double check. Okay. Just want to double check. Virtual machines, please. Okay. Oh, why does it only take? Sorry about that. They changed something here. So you can now see here, I have my Azure virtual machines and I have my servers. You can see here they're running, they even have the name on premises. And they're also joined to a resource group, to an Azure region, and to a subscription. And then I can even use tags here to actually define the location or a cost center. So I want to quickly show you something. So I'm going to deselect that. And I just want to see all my servers from a specific cost center. So I have a cost center here. And I only want to see all the servers from cost center 1001. So I'm going to do that. And now you can see here, I can see my server running in Azure, my Azure VM, which is a Linux VM. And then here my server, which runs outside of Azure, underneath my desk or in my own data center at the same time. And they look like an Azure resource. Now you might say, Thomas, okay, this is great now. I understand that I can now use this to organize and manage my Azure resources, right? But I want to do more. I want to not just see them. I don't just want to organize them. I also want to do more. So one thing I want to show you is Azure Policy. So Azure Policy is a way, for those who don't know, is a way to configure your Azure environment. So when you, for example, give IT administrators or developers access to your Azure environment, they can go out and deploy everything, right? They can deploy where in every region they want. They can deploy like large virtual machines and so on. And we have this great thing called the MV2 series virtual machines, which are virtual machines with a couple of hundreds of virtual cores. I think over 20 terabytes of memory right now, and they drain a credit card in like 3 seconds. So you don't want everyone just go out, deploy the largest virtual machines, right? Because they're the fastest. You also need to have control. And at the same time, you will still want to give them the flexibility. And Azure policies now allow you to do this. So you can actually limit the Azure environment and say, hey, this is the way it can be deployed. What a lot of people don't know, there is another thing, part of Azure policy, which is called Azure Guest Configuration Policies. Now, Azure Guest Configuration Policies are helping us to configure and audit the operating system of an Azure virtual machine. So what I can do right now is I'm going to create a new assignment of such a policy, and I'm going to show you how that looks like. So I'm going to assign an initiative. An initiative is just a collection of policies. The first thing I can do here is I can select the scope. This can be a resource group, it can be a subscription or a management group, and I can just select, okay, where does this policy work? And then I can also go and define a definition. So what I have here, we have in Azure, we have a couple of built-in definitions. So for example, we have some of them technical ones. So this one does deploy the prerequisites for guest configuration policies. This one enables monitoring. We also have some, like for example here, which is government standards. So we help you to implement standards like UK official, ISO, PCI, the federal things of Canada, the US, and so on. But what I want to show you is very simpler. I want to show you one with which goes out and basically audits virtual machines or machines with insecure password settings. So this policy goes out and sees, hey, this operating system, Windows or Linux, has insecure password settings, right? So for example, the password is not long enough and things like that. So I would just select that and then select it. I would then go and create that, but I'm going to cancel this because I already prepared it. Like in a good cooking show, I already prepared the whole thing because this will take a while until it audits my environment. So what I can do here now, I can go to the compliance view. And if you can see here first that I don't do a good job of being compliant. So I should probably fix that. And then here you can see on the bottom, you can see the different policies I assigned. You can also see that I'm here not compliant. And then if I scroll down, I also have a couple, luckily, where I am compliant. So I'm more interested in the one I just showed you. So we have here the one which is auditing VMs for insecure password settings. Now you can see that I'm not compliant. You can see that something is not good. I can also see that I have a couple of resources. You can see here the rules or the policies which I'm not compliant. You can see here some of them are not compliant, some of them I am, so that's good. But what I'm actually interested is to see what servers are not compliant. So if I click on non-compliant resources, it will take a moment to load, but then it shows me here on the top, for example, my Azure VM, and on the which is not compliant. But you can also see that here, I can also now see, thanks to Azure Arc, I can also see my on-prem server here, which is a Microsoft.hybrid compute machine. So I can see that that server running here does also not have the right security policies, right? So this is pretty great, I think, to get an overview about how are you compliant, how is things set up about all your servers, not just necessarily in Azure. So I want to quickly switch back and show you what we actually did here. So this is a high-level Azure management architecture slide, like to show you the management and of Azure resources. No worries, there's a lot on the slide, and we'll go through what it means. So let's start on the left side here. We, as Azure customers, we use tools like the Azure Portal, PowerShell, Azure CLI, APIs, the SDKs to interact with Azure. And when we're interacting with Azure to manage our resources, we are interacting with Azure Resource Manager. Azure Resource Manager is basically the magic how we can organize our resources. So for example, it gives you role-based access control, logs, subscription management. It gives you all that search and tagging and grouping, policies and blueprints and all that flexibility and much, much more. And then on the top, you can see here, we have the management services for monitoring, update, management, backup, security, and much, much more. And until we announced Azure Arc, you can see that on the bottom, we were only able to use Azure Resource Manager for services which were really running in Azure, right? For Azure services, that can be virtual machines, web apps, databases, and Kubernetes clusters, and so on. But they had to be in Azure. Now with Azure Arc, we are actually extending the Azure Resource Manager to allow us to connect services which are living outside of Azure. So for example, servers, Linux and Windows servers, Kubernetes clusters, databases, and maybe much, much more, which then can take advantage of Azure Resource Manager and our management services. Now, I also want to highlight that this should not be like this Azure Arc should not go in and just replaces everything you have. We don't want to create that dependency to Azure, right? So you can still use your local management tools. So if you have server admin tools, you use PowerShell, you need Kubernetes tools, you have your Azure Data Studio, you can still use those. There's no dependency then, like if Azure is not available, your things do not work. But it gives you that additional management capabilities. And so let's have a look on how we actually can do this. So I go back to my Azure environment. And if I want to add servers and Kubernetes clusters or databases, what I go is I look for Azure Arc in the Azure portal. You could either click there or you can search for it here and you can find Azure Arc. And now you can see here I'm now in the Azure Arc Center, if you will. This is where I basically can connect all my resources, my hybrid servers, my hybrid Kubernetes clusters. Oh, someone is on mute. So what I want to show you here. Perfect. Okay, muted. So what I show you here, you can then add your infrastructure like servers, Kubernetes clusters, and so on, and then also data services. You can find here also, if a lot of people are asking me about pricing, you can also find more information about pricing here than directly. And then you have a list of different things we can onboard, like as I mentioned, servers, Kubernetes clusters, SQL servers, databases, Azure Stack HCI, and much, much more. Now, when I want to add a server, I can just click on servers here. And you can see here, these are the servers I showed you before. These are already added to my environment. So I can here press a button to add a new server. And how that works is we're actually going to deploy an agent to a server, which then connects to Azure, right? That is what we're going to do. And you could read the documentation and download the agent and do everything by yourself. But we want to make it easier. So we have these two methods here, which are like basically wizards to explain you how to do it. The first one really generates an interactive script. So you can, then that's what we will do. We will create a script. You can copy that. You can run that on your server, and this will connect your server to Azure. You will need then to log in while you run that script to make that happen. So if you're onboarding multiple servers, like hundreds of servers, you probably don't want to log into every single one of them. So there's also a way of using a service principal name so you can automate that process. But to make it easy, we're going to generate that script now. And you can see here what we're actually going to do and what the requirements are. So you can see here we need to have outgoing port 443 to the internet, or basically to the Azure APIs. So it doesn't need to be everything in the internet. It just needs to be some URLs from the Azure APIs for Azure Arc. And then you need to be local administrator. And obviously, we need to have a resource group. So in the next step, I select the subscription where I want to join these servers and the resource group. So I already created one here, Azure Arc servers here. I then select the region I want to join. So these are all regions. It doesn't matter. You can see I only have a small amount of regions. It doesn't matter. It just needs to be the closest region to your location. It's not about that anything like data gets transferred. It's only meta data, like the server name and things like that, where the agent connects to. I can also select which operating system I want to use. It can be Windows or Linux. And if it's behind the proxy server, I configure that as well. I can then configure tags, which I showed you before, like cost center and other things. You can also do that later. So we're going to do that later. And then at the end, we get that script. And that script will do nothing else than download the specific agent, install the agent. So this is in the Windows world, this is a MSI file, and then run a command to connect to the specific Azure tenant, the Azure subscription, and the Azure resource group, so that server shows up. So I download this or copy it and then run it on my server. I log in with my Azure account, and a couple of minutes later, the server will show up here, right? So it will be here in that system. So what I can do here now, if that server shows up, I can click on it and I can find a little bit more information. So you can immediately see that this looks like an Azure resource, right? It's part of a resource group. It's joined to a location. It's part of a subscription. You can also see the tags here where that server is running. You can also on the left side here find the activity log. You can also get configure role-based access management. So this is a great one. So if you have, for example, admins for a specific application, you can only give them access to their servers and not just to everything else, right? They don't need to see every single server in the environment. They only need to see the servers which are they're responsible for. You also see some additional information like the computer name, and you can see that this one, for example, is joined to a local domain. You can see which operating system it's running and so on. You can then on the left side find even more interesting stuff. So first, let's have a look at settings. Some of you maybe are familiar with extensions. So we have VM extensions. VM extensions, and please forgive me, I will zoom in a little bit more because then you can see it better. This is like the same thing as you have for Azure Virtual Machine. So you can deploy some VM extensions, which then allow you, for example, to run a custom script or PowerShell desired state configuration, or to install the log analytics agents, which then even gives you more capabilities. So you can see here I already done that. So I installed already the monitoring agent. This gives me some more tooling. For example, I can now go into security. I can find some security recommendations. So this will help me to figure out, hey, is my server configured securely or not? So it gives me some information about this using recommendations from Azure Security Center. I also want to show you more. There's absolutely more now. I can, for example, go and look at the logs of this server. So if I configure it, you can see here I get access to log analytics. You can see that I have now here access to all the log files of that server. So I have like the application log, the event log, and so on, which I could actually look at. You said probably, Thomas, I was able to use that before with Azure Log Analytics And yes, that's absolutely correct because we're using the same technology here. However, the difference was that when you wanted to give someone access to the logs of a server, you needed to give them access to the log analytics workspace. So they could see all the logs of all the different servers. Now with Azure Arc, they can basically only see the logs of that specific machine they're allowed to see. So in the middle here, we can now run our log queries. And I already prepared one here. This uses the keyword query language. Some of you also maybe know it as Custo. So I can run a query. This is a very simple one here, very, very simple. Just gives me the update information of that server. So I can see here what is going on with that server, how many updates are missing, and so on, right? But I could go to the system event logs. I can go through the security event logs, whatever I configure. With that, I can then also use monitoring. I can use Azure Monitor to monitor my server here. And the first thing I want to show you is the performance monitor. So I can now see of that server, I can see how much disk space is still needed, how much is free, how is CPU utilization, and you can see here, there's not much going on with that system. You can see the memory consumption of that system. You can see IOPS, for example. You can see that like the throughput, disk throughput, latency of the disks, how fast the disk is. You can see here network throughput, so you can see here what's actually happening, how much data does it send, and so on. The other thing I want to show you is the dependency map. So I'm going out here quickly, and you can see here, no worries, I will zoom in just a bit. You can see here our server, and we can see to which ports he is actually connecting. So if I'm looking at this, you can see here this server is connecting to port 443 to 10 different servers or endpoints. So if I click on this, you can see here where he is connecting to, where that server is connecting to. So you can see here, for example, this one connects obviously to the Azure Arc API. That's one thing. But if I go down here and have a look at, for example, this one, there's also port 135. You can also see that this one, for example, connects to a local domain controller here running here in that environment. So this gives you a great overview. You can actually quickly see what is this server doing, where is it connecting to, and much more. Now, speaking of that, I can also do inventory. So what I can do here is I can see what software is installed on that specific server. So I can see here the different installed updates. I can also search. So I want to see if that server has Edge, Microsoft Edge installed. So it does have Edge installed. So I find that these updates here. So I can know that I probably shouldn't have Edge installed, or maybe it should, depending on what I want. But I can find the software installed on that server. I can also see the registry and the services running. Now, I also want to see, for example, the changes, right? So I want to know what changed on that server. So if something happened to that server, I can go out and have a look at change tracking and see what were the last events happening. So I can see here that, for example, a service changed here, like different services. I can also see if there would be like a file change or whatever. I can also go to policy. I showed you that before. Now I just see the policies which are assigned to this server. And you can see here, for example, the insecure password one, I'm not compliant with that. So that server is not compliant. So I can actually go and fix that. There's also another one I want to show you. I have a policy set up which says, okay, all my servers need to be configured with that specific time zone. So I can see that that server is not compliant. You can find more information here. And now I know as a server admin, I need to fix this. So I could go to that server and change it. Or here I could create a remediation task, which then will help me to actually fix that time zone and change it to that specific setting. Now, one of the most troubling things is updating servers, right? That needs a lot of time, a lot of organization, a lot of thinking, and so on. So what we have here is update management. Now we can have update management here. So you can see here all the missing updates of that server. You can see here that these are only preview updates. So that's why I'm compliant is good. But if there would be a critical update missing, it would say, hey, you're not compliant. But let me install these updates. So what I can do here is I can schedule an update deployment. I can then give that update deployment a name. So let's call that WAC server update. Again, this is just a random name for that job. It automatically detects that this is a Windows VM. If it would be a Linux server, it would also show that. I can then configure how long it can actually install updates. And then I can configure if it should reboot afterwards. So I can say reboot if required. That sounds pretty good. I can also say never reboot or always reboot. Reboot if is required sounds actually good, right? Makes a lot of sense. And now it would be, I could actually go out and update now. This would then install updates on that server in the next 5 to 10 minutes, which is probably not a good idea because I'm doing a presentation right now. Or also for companies, obviously, you don't want to do it during your work hours, right? You want to do it outside. So you can go out and schedule it and set the different time here, whatever you want. And then you can also make it a recurring task. So you could actually say every Tuesday, I want to install updates on that server. So this will then go out and every Tuesday install updates. You can then also configure a little bit more. You can say what updates should be installed. In my case, I want everything to be installed. I can include specific updates or exclude specific updates, and then also run a pre or a post script if I need to do some additional configuration. And then I could actually go and create that job, which I'm not going to do right now, but you get the point. Now, a lot of people tell me, hey, Thomas, look, this is great, but I don't like, I have 20 servers. I don't want to do that for 20 servers, right? I mean, it's too much work. So yes, you can also do that for groups of servers. So this is not like change tracking, inventory, and update management. These are not necessarily new technologies. We just put them into Azure Arc, but they have existed for a while. And they are part of Azure Automation. So if I click here on manage multiple machines, it will bring me to my Azure Automation account here. And you can see here I'm in update management. You can also see I have change tracking and inventory as well. And now I can see here my Azure, my Azure VMs as well as my non-Azure servers. And I can see here like some of them have updates missing. Some of them are just running fine, right? So you can see them here. And now what I can do here, instead of now going for every single server, I can click here and select a group of servers. So I can actually create a group of servers and then update them every Tuesday, for example. I can even go that far and create dynamic groups based on the tags I showed you before. So I can create a tag called, for example, update group. And then I can configure it that all servers in upgrade group 1 get updated on Tuesdays, and all servers on upgrade group 2 get updated on Thursday. So if you have 2 domain controllers, you would update the first domain controller on Tuesdays and the second one on Thursdays, right? So they don't go, both of them go down at the same time. So that is things you can do. I was speaking a lot about servers. I also quickly want to show you that the same thing also works, for example, with SQL servers. So here I joined a SQL server, and what I can get, you can see here, it looks almost the same. I can also get some security information, and here I get additional security information for the SQL configuration, right? So I get some information on that as well. And again, I can do much, much more. I also want to show you here how I manage Kubernetes clusters. So I have 2 Kubernetes clusters here. They're not in Azure. They are just connected to Azure using Azure Arc. So here, for example, this one, I have the information here. I get some tags here. You can see here, again, I have also monitoring. So I can see what is happening on that specific Kubernetes cluster, right? So I can see here the same thing, node CPU utilization, memory utilization, node count, and so on. So you get all that information for Kubernetes. You can also use policies for your Kubernetes cluster. So the same thing as for virtual machines or servers. You can also make sure that your Kubernetes cluster is configured securely. And then what I can also do is something called the app configuration or configuration, and this uses a technology called GitOps. So if I have multiple Kubernetes clusters, for example, and I have an application based on containers, I want that application to be deployed to these Kubernetes clusters. With that technology, I can actually create a Git repository, store all the settings, and I can show you this, for example. Like, let me do this. I quickly, not 100% sure. Do I have it here? Don't think so. Just give me a second. Yeah, okay, I'm not gonna do that. So what I can do here, I could store that configuration, and then it would be able to deploy that to the Kubernetes cluster. Now, when I do a change to that application, it would then update the Git repository, and at that moment, it will then automatically deploy that change to those Kubernetes clusters, and all the applications would be up to date. So pretty great way of doing this. So let me jump back here to the slides. So I want to give you some key takeaways here of what I just showed you with Azure Arc enabled servers. So first of all, with Azure Arc enabled servers, the things I just showed you, we had Windows and Linux servers. They can be physical and virtual machines. They can run in your own data center, office, or even another cloud provider, and they're completely domain agnostic. You can also do governance and security. So for example, I showed you how you can use policies and security center to make sure that your servers are configured securely. You get role-based access control, and this is important one again. You can only give access. You can give access to the admins which need to have access to these specific servers. They don't need to see all of the servers, only the ones they actually should work with. The great thing also, if you're a managed service provider and you're using Azure Lighthouse, Azure Arc works great with Azure Lighthouse. And then we have obviously management at scale. That's the things I showed you at the beginning. You can now see all your servers in the Azure portal. You can also use the CLI and PowerShell to do that. You can use tags. You can find all your systems in one place, and you can see if they're patched correctly and so on. So this is a great thing to manage resources on servers at scale. Now let's go a step back. I only was able to time limitations. I cannot show you everything. There's much more to Azure Arc. So what does Azure Arc do? What are the current things we can do? One thing, again, as I mentioned, is organize and govern our environments, Kubernetes clusters and servers. That's the thing I showed you. We can also do, as I mentioned, the app management on Kubernetes clusters at scale using DevOps techniques, using GitOps, again, where we can check in changes into a Git repository, and then these changes will be deployed automatically to the Kubernetes clusters. And then the last one, which I mentioned briefly at the beginning, is that our customers are able to deploy Azure data services wherever they want. So what they can do, they can actually go out and deploy Azure SQL in their own data center, right? So this was a huge request, obviously, from a lot of customers, and that's one thing which is also part of Azure Arc to deploy these services anywhere. Now, I know that a lot of people in this call are very technical, so I want to quickly also do this last technical slide here. Again, there's a lot on this slide, so we start on the left side. This is a little bit of the architecture of Azure Arc. You can see in blue everything Arc related. So if we start on the left side, if we are as a customer, we basically use the Azure portal, the Azure CLI, the SDKs, APIs, PowerShell, and so on to manage our resources. And we are actually interacting with Azure Resource Manager. And what you can see here in blue, all the Azure services, basically, they have a resource provider, an RP, which is basically the technology behind that functionality. And then you can see on the bottom, for example, we have one Azure resource provider for servers, for Azure Arc servers. So you can then see that the agent, the Azure Arc server agent, connects to that resource provider. If we go to the middle one, you can see here the same thing for Kubernetes clusters. We also have an agent and then a resource provider who connects there. And then we also have one for data services. And here you can see what I mean by data services. So it allows you to deploy SQL and PostgreSQL to your environment. And the only thing you need, by the way, to deploy this is a Kubernetes cluster. So if you want to run Azure SQL in your own data center, you will just need to have a Kubernetes cluster in your own data center, and you can actually deploy Azure SQL on top of it because the whole deployment is container based. And then again, as I mentioned before, you can still use your specific tools, right? Your local tools for server administration, Kubernetes management, Azure Data Studio to manage your databases. You can still use that as you have before. And then the last thing, I want to make another step back and show you again our slide with all our hybrid technologies. Again, Azure Arc is just one part of our hybrid story. Because I'll often get the question, does Azure Arc replace Azure Stack? And the answer is no. It really is our two separate solutions and two separate offerings for depending on our customer challenges, what they need. But they can also be combined. So our customers could, for example, run Azure Stack Hub and container engine on top of it, and then connect that Kubernetes cluster using Azure Arc to Azure. So you can bring that together. And again, we also have IoT solutions. We have a lot of other management solutions and identity and security solutions as well. So we really prioritize hybrid for our customers. So with that, I want to say thank you very much. I will quickly have a look into the chat window to answer some questions. So again, it was, before I start with that, I want to say thank you everyone for listening. It was a great honor to be here today. So I'm going to have a look if there are any questions. So if you have any questions, feel free to reach out to me. I usually get one question about pricing. So I want to quickly show you the pricing part before, because we still have a little bit of time. So I'm going to show you that. So if you go to pricing here in the Azure Arc portal, you can find more information. Now, the great thing about Azure Arc is the basic functionality of, for example, servers, and is at no cost, right? So you can use this functionality here for servers for free. So you can connect your on-premises server to Azure without any cost at all. Then there are paid services. So if you want to have some additional functionality, which I showed you, for example, Azure Monitor, Security Center, policy, automation, then you will have some additional costs coming with that. So I think that is very important to understand. You can find more information here. Now, Azure Arc servers, this is actually in GA right now. So that means general available. So you can actually go out, it has full support, you can work with it. And the Kubernetes and the data services part, as you can see here, they are currently in preview. So you can also go out and try them out. And they are actually, at the moment, they are free because they are in preview. So don't use them in production environments, but you can actually go and try them out at no additional cost. And you can figure out how they're working and provide us with feedback about what you think about these services. Good. So let me see if there are no more questions. Oh, love the session. Thank you very much for the feedback. Really enjoyed being here. Oh, there's a question. Okay, can Azure Arc be used in managing Windows Server hypervisor? Oh, this is actually a very good question. So I get that question a lot. You can add Hyper-V servers, and you can run the also connect the VMs running on Hyper-V, so you can add both. However, at the moment, there is no functionality to manage the Hyper-V hypervisor. So you cannot go out and create VMs on Hyper-V. However, we get that feedback a lot, and we already get that to the feature team. So they already know that this is maybe something. However, what I want to show you quickly, I can also show that because, again, great question. You can see here, if you're using Azure Stack HCI, which is basically Hyper-V, we're already working, I don't have it here now, but we're already working on technologies to connect your Hyper-V or Azure Stack HCI cluster in that case. And then you can also go out and create VMs on your local Azure Stack HCI cluster. So that will be something which is coming. Again, you can see here it's in Azure Stack HCI is in preview, but for normal Hyper-V cluster or Hyper-V server, we don't have that functionality currently present. But great question.
Hello, Thomas.
Yes, hello.
Yeah, I can see there are other questions. Someone was asking, how does one become a Microsoft Cloud advocate? And there's
Yep, that's a great question. I get this is also something I get a lot. So very importantly for our job is obviously working with the communities, right? So doing like when if you are doing things like a Microsoft MVP, and I know some of you are in this call are Microsoft MVPs, you're already doing a great job, which is basically kind of like being an advocate. Now we are usually looking for advocates. Let me quickly take that over here. Just give me a second. With this, I will show you the link. Just give me a second until I find the website, which then actually careers Microsoft. This is definitely one. So yeah, so let me quickly show you this here. So we have this website here where we actually add new jobs. So if where we find all the information for the different openings and roles, where we looking for example, new cloud advocates. So you can see here the URL. Let me zoom in here a little bit for those who are interested in that. Again, there's a lot of information on what we are looking for on these pages. Again, very important that you're actually working with the community, that you're sharing your stuff, your knowledge, that you're helping others to become better, that you like learning and sharing, like not necessarily need to do presentations, but like to do writings or videos or like different things. And you have helping with user groups, for example, doing your presentation. There's many things you can do. And again, I just want to highlight that link so you can check that out. And you can also see that some of these jobs here are country specific, but some of these jobs are, for example, worldwide. And you can also see we have other jobs in our organization as well. Like, for example, we have software engineers. We're also looking for content developers, program managers, and so on. And these are just the jobs within the DevRel organization. What I would also recommend is to have a look here at careers.microsoft.com. This is where you can find all the different job openings at Microsoft. So basically every job here at Microsoft is on that page, and then you can just search here for jobs. You can also look at specific countries. You can look at like worldwide jobs and so on. So this is where you actually can go. Again, for being a cloud advocate, it is important that you're working with the community, helping others, sharing your information, your knowledge. I think that is very big part of it. And this is also the parts how you, for example, become a Microsoft MVP. And again, I know that we have a lot of Microsoft MVPs in this call, so I'm very proud of the work you're all doing. Really appreciate that. Everyone in Microsoft loves people, like not necessarily just need to be MVPs, but like everyone who shares their knowledge and helps others. I think that is very important.
Okay, thank you so much. And you can see there are more questions in there. Yes, still there. And I don't know if you are seeing them. Someone is asking, is Microsoft Learn sufficient to prepare as for Azure exam?
Yes. So that's a good one. So what I usually do for Azure exams, I do two things. So I wrote for different exams. If you're searching on my website, I will put this link into the in the chat window. is a study guide. And this is explaining how I prepare for the exams. And I have this for different exams, also for AC 900, for example. Here you can see other exams as well. And usually what I do is I go and read the skills requirement. You can find them on the exam website. And then what I'm doing is I do take care of Microsoft Learn. So for those who don't know, Microsoft Learn is a free learning platform, which you can go out and you can do learning modules, not just for exams, but also for other technologies you want to learn about. Azure, Microsoft 365, identity, even Dynamics, Windows development, and so on, much, much more for that. So I'm definitely doing these. Usually I listed them here. But then what I also do is I go through the skill measurements outline. And this is all the information which is basically asked or which you should know in the exam. So they have a huge list here of things. And what I usually then do is I go out and read the specific Microsoft Docs pages. So for example, one is asking one of the parts you need to know is configuring Azure DNS. So what I do is I go to Microsoft Docs and I read about Azure DNS, and I do that for all of these single topics, and that usually is enough for me. So I do Microsoft Learn, and I do read the Microsoft Docs about it. I obviously also try things out to get a better understanding. So there's a possibility to create a free Azure account, azure.com/free. So you can go and try it there. That's one part. However, if you create a free account, I think you will need to have a credit card. Even though it's free, we will still ask. So you can go there or Microsoft.com/learn. So for those who don't know, this is absolutely a great platform for learning. And this is free. The only thing you can see here, you can browse through the different learning modules. You can go in and basically read about it, and you can try out things. It even gives you some free Azure sandboxes. So you don't need an Azure account, you don't need an Azure subscription, but you can actually go out and try out Azure. So Microsoft Learn, very great platform for everyone to learn. I also have a question here about Azure Arc, if it's possible to like replace SCCM and SCOM, for example. So that's a very good question in these topics, because I believe SCOM and SCCM are very mature products to manage your on-premises servers and obviously also clients in that case. It depends a little bit. It depends on what you need. I think you need to compare the. Oh, I heard something. You need to define if you can really do everything with Azure Arc. However, if you're living in this not just on-premise environment, but you have multiple environments, then Azure Arc can provide a much higher level view of everything which goes on. Because like SCOM and SCCM are great if they're in kind of like single location. But if it's as soon as it comes to like you're running everywhere at every different possible stage, it's going to be very difficult, and it's much easier doing that with Azure Arc. You would really need to check if one is enough. For some companies, Azure Arc is enough. For some companies, they still need SCOM and SCCM because they can just do more with it right now. But that will probably change over time. The more features we add, the more we bring to the table. So I see I'm already over time. I apologize for that. So I want to again say thank you very much. It was again an honor to present today. I really love to be here. Again, feel free to reach out to me anytime. And I think next up is Stevie, a good friend of mine, Stevie Buchanan.
Thank you so much. We are really, really happy. We appreciate your time and effort. We really enjoyed the session. Thank you.
Thank you very much for having me.
Lawrence?
Hello.
Hi.
Yes. Who is
Hello.
this? Yes, can you hear
This
me?
is Abu. Yeah,
Abu,
this is
how are
Abu
you?
Lawrence. I'm fine, and you?
Very good.
Okay. Welcome to Ghana again.
Yeah, it's been 3 years.
Yes, yes, yes. We are
Right.
happy to have you here.
Thank you very much. Thank you to all for extending me the opportunity to present, as usual.
Can you put on your video so that some of us will see you? There are some people they are just they've never seen you before.
Hi, Abu.
Yes.
Yeah. No, I got bandwidth issues on my side, so I'm barely battling with bandwidth. I'll try as soon as my presentation's over, if that's okay.
Okay. Okay. That's fine.
Can I go?
Yes, you can go ahead, please.
Thank you. Thank you, Thomas, for that absolutely excellent, well-delivered session. I mean, I got to try out some of the features of Azure Arc for a customer a couple of days ago, and it was absolutely amazing. Give me a second here. And it was absolutely amazing how on parity those resources look compared to an Azure resource. So from a transparency perspective, from a management perspective, it's absolutely brilliant to see how far Azure Arc has come. So today I'm going to talk to you about Azure Sentinel. Just a little bit about myself. So I've got a I would like to say a relationship with the Ghanaian team. I think I was there in 2018. It was, and we delivered an Azure bootcamp, and it was really a memorable event. I got to make a lot of friends. I think that's where Abu and I, started conversing technically. And today he is an Azure MVP, and I see him spreading the message and sharing the beauty of the Microsoft Cloud, and it's great to see. So I'm Lawrence Reddy. I am a Microsoft Azure MVP, and I became an MVP in 2017. I've been working with Microsoft technologies for about 22 years, so it's been a while. And I've been doing Azure for many years, and it's all that I do for customers. I do a lot of work with financial services in South Africa, education. I've been involved in a lot of NGO projects, including initiatives to combat wildlife crime. See, there's an echo there, Abu. Okay, it's gone. So what is Microsoft Azure Sentinel? Now, Sentinel is basically a scalable cloud native security information event management and orchestration solution. Now that's a mouthful. So let me explain the problem before I explain the need for Sentinel. We are getting extremely sophisticated in terms of our use of technologies, whether that's in devices or whether it is cloud services, technology at your fingertips. Unfortunately, data is everywhere, and so are bad actors, and so it's extremely difficult to keep up with threat actors or bad actors or hackers, right? They are far more experienced in what they do. Some of these are state sanctioned individuals or groups of individuals. They have a global reach, which means they can reach anywhere at any time. And the thing that they hold as a secret weapon is anonymity. Anonymity meaning we can't see them, and you can't really see see the relationships between interactions with your data, who's accessing your data real time. It's very difficult to actually visualize it. You may know where your data is, but the relationships of that and who's accessing it, when they're accessing it, how are they accessing it, there's far too many touch points, and therefore potential opportunities for these individuals, groups of individuals. So what we need is a SIEM that can handle these visualizations, can handle these threats, and can handle these detections, and can handle these analytics at global scale, which means, and deliver these real time. So Azure Sentinel is Microsoft's cloud SIEM that can deliver intelligence, security, analytics, and threat intelligence across the enterprise. And it's a single solution, right, for alert detection. Now, the problem statement, when organizations now want to deal with the problem that I just mentioned about threats and attacks and state-sanctioned individuals, is the issue of when they put these SIEMs in place, whether they put these on-premise SIEMs in place, they are cumbersome to manage, they're expensive, infrastructure and manpower to maintain. Because the data sources are so diverse, it's very difficult to get a real view, at any point in time of what your security posture is. I'm not saying it's impossible. I'm saying there's just too many data points. And I think the biggest issue with the traditional SIEMs is alert overload. Alert overload means that it's just generating far too many alerts, or creating far too many incidents for there to be any meaningful response. And what tends to happen is that organizations with these SIEMs, they become sluggish to respond to threats, because if you don't respond to a threat at the time that it could be detected, the attacker is going to move within your organization fairly efficiently. Okay, now that brings me to Azure Sentinel. Now I've given you a problem statement of what we're dealing with as enterprises and organizations, and essentially why we IT guys are in the game. Why there's such a demand for skills like ours. And I've also given you the problem of traditional SIEMs. So why a cloud SIEM then? Well, it can collect data. The whole aspect about dealing with threats is the collection of data, collection of logs. Right? You need to be able to collect that, or have a mechanism to collect that across your users, your devices, your applications, your infrastructure, your on-premise, and multi-clouds. And you need to collect that efficiently. Then you need to be able to detect previously undetected threats. Meaning that you need to be able to pick up threats that would otherwise have been gone unnoticed, because it's a proprietary solutions and it can only do XYZ. The other big issue with SIEMs is the false positives that are generated. So you want a cloud SIEM, and this is where Azure Sentinel comes in, where it's a cloud SIEM that minimizes false positive. The last thing somebody wants is to be able to detect a threat, send a whole bunch of resources to it, have a whole bunch of security analysts work on those threats when it's actually a false positive. So you want to be able to deal with meaningful threats. So an event was triggered, an alert was generated, multiple alerts were generated, an incident is created, and then a security analyst is then brought in to do hunting. So the thing is, you want a cloud SIEM that is accurate, and that can minimize. I'm not saying that there won't be false positive, but I am saying that it is the whole architecture is predicated on reducing false positive. The next aspect about a SIEM or a cloud SIEM is the ability to investigate, like any typical investigation, right? You see a pattern, you need to have the tools to kind of drill down and find entities, whether those entities are users or whether those entities are our systems, and to correlate relationships, or to correlate incidents, or to correlate alerts, and then to start to visualize which entity was involved and what is their pattern, what is their threat pattern, which I will go through now shortly. And most important of all, I think the most important part of this whole cloud SIEM cycle that Azure Sentinel is built on is the ability for you to act, for you to act quickly, whether it's manual investigation, whether it's manual response after an investigation, manual response, or even an automated response. An automated response is a set of playbooks, right, built on Azure technologies that can allow you to mitigate and to mitigate a threat before it happens, because human beings are not going to get to everything all the time. That's just never going to happen. And the issue is that you can't have a SIEM that's predicated on the availability of humans. You want to have an engine that augments humans, or humans being able to intelligently respond to meaningful data. And I think that's what Azure Sentinel does. Azure Sentinel has got the tools, the AI engine underneath the scenes that allows that allows a human to be able to analyze a threat that is very close to being a threat. Before I get into some of the demos and breaking down some of the pieces of all the things that I mentioned. So essentially, guys, for everyone on the call, it's collect, detect, investigate, respond. That's really what it is about. You're going to hear quite a few technical concepts being used, but they're all part of this whole collect, detect, investigate, respond. Now, the thing that I want to quickly talk about is I do security analysis for organizations, including financial services. What you need to realize, and I'm just going to give you a background in terms of the way potentially a bad actor or a threat actor or a hacker will operate. And for those of you who would like to do some reading, read up on the MITRE ATT&CK framework, MITRE, MITRE ATT&CK framework. Now, it's a set of principles that have been used quite widely, but it's starting to be adopted as a very trustworthy set of guiding principles in terms of how to deal with threats. And it surfaces how attackers work, right? It surfaces the techniques they use. So what I'm going to do is I'm going to go through some of them now very, very quickly. But if you want to read up on it, just look up the MITRE ATT&CK framework. The first attack vector that an attacker will use is something called initial access. So initial access is techniques that are used by the adversary to obtain a foothold within a network. Now that could be from a spear phishing, or it could be exploiting a vulnerability. It could be as simple as sending an email targeting a user to change their Office 365 username and password and gain access. Now, it's very important for you to understand that Sentinel is not a magic bullet, right? It's predicated on the fact that you are using, if you are a Microsoft customer, that you are using the technologies like Office 365 and Microsoft 365 and DLP, and data exfiltration protection, identity protection, and there's all sorts of technologies that can allow you to implement a defense in depth strategy. So in order for you to prevent the attacker's initial access, you can't just deploy technologies without having some sort of structured deployment framework. And this is where hackers can gain a foothold, even in very, very advanced cloud environments, even with customers that have Microsoft 365 and those technologies, right? Because you're deploying those technologies doesn't mean that you can run away from best practice. So that initial access is what an attacker would use. The next aspect is execution, or the next technique they'll use is execution. And this is a technique that results in an adversary that runs code on a target system. Now, for example, what a hacker might do once they gained initial access, they will run a PowerShell script to download additional components on other systems, right? The next technique is persistence. So techniques that allow an adversary to maintain and remain connected to a target system, even following reboots, and credential changes, and even an initial set of mitigation techniques. So they could have been detected, right? And it may be that being detected was what they wanted, because they can then trigger a secondary payload. So persistence is a third technique that they'll use, and potentially what they could do is they'll create a scheduled task, and they could run their code at a specific time or reboot. Just when the individual thought that they got rid of the code, it changes, and their presence could now morph into another another malicious entity within the target system. Privileged escalation. Now, this is when a technique it's when an adversary gains higher level privileges. So guys, the things that I'm going through now, these are the sophisticated mechanisms that attackers use. The reason I'm going through these is I'm going to show you how Sentinel is able to use different, it in itself use different techniques in the collect, detect, investigate, respond phase to actually, highlight these techniques used by the hackers. The fourth technique used by an attacker is called defense evasion. Defense evasion is it's simply what it is. A technique used by attackers to avoid detection. Now, your normal antivirus software, guys, is not going to cope with some of these. In fact, it's not going to cope for a lot of these. So do not, under any circumstances, think that you're dropping down, an antivirus protection. And this is the false, sense of security that a lot of customers fall into. And you have to have a defense in-depth strategy to be able to deal with this. I won't get into the other ones in too much detail. Credential access, being able to steal usernames and passwords. Once they get in, they'll go after the NTLM Active Directory accounts. Lateral movement. Okay, you may have heard of this. What is lateral movement? Lateral movement is techniques that allow an attacker to move from one system to the other. And that's what they do, right? And basically pass the hash methods of authenticating users using RDP, moving from one system to the other. Collection is another technique used by an adversary to gather and consolidate information they were targeting as part of their objectives. And this could be espionage. Their purpose is to get in, collect data, and get off, right? Command and control is another technique. It's used by an attacker to communicate with the system under their control. Exfiltration, very dangerous. It's moved data from compromised network to a system or network fully under their control. And I mean, the others are the impact, technique used by an attacker to impact the availability of systems, DDoS. I'm sure you guys have heard of DDoS. But those of you who are developing Azure systems out there, these are all part of the scaffolding and the cloud adoption framework when you are building systems to protect from these. So it's not just, let's just put Sentinel in and we automatically get this protection. Okay. So let's go through Sentinel. Now that I've kind of created a very gloomy picture in terms of just how sophisticated these attackers are, how does Sentinel deal with this? Okay, so the first thing we need to do is we need to connect the data, right? Connect the data mean you want to give Sentinel line of sight of the data, and it's on onboarding Sentinel in your environment. I'll show you a demo on how we do that now. So Sentinel comes with a number of connectors, right, for Microsoft solutions and non-Microsoft solutions. And some of these are Microsoft 365, Microsoft 365 sources, Microsoft 365 Defender, Azure AD, very important, Azure AD. Azure AD is the basis of identity. Well, it's the basis of identity, right? There is no other identity platform that is capable as Azure AD. Even if customers are using AWS, they're more than likely going to use Azure AD because with Azure AD, you can protect the identity. So you can plug in the Azure AD source into Sentinel, and you can start getting, you can start profiling, not profiling, you start to see whether you are starting to see logins coming, simultaneous logins coming from different locations. That's the first sign that you've been compromised by a phishing attack. And other technologies like cloud app security and much more. And there's also built-in connectors, right? I mean, you can ingest logs from your firewalls and your FortiGates and your checkpoints and your Barracudas. There's also, if you support, you might say to me, well, is this thing proprietary? The answer is no. And I think that's what Microsoft's been doing great for many years, is that everything is in a standard open event format. So, and there's a REST API for you to connect a syslog, for example. So there's a REST API for you to securely send your logs from source to destination. I will show you, I just want to cover the high level, how this thing works before I get into some of the demos, right? And by the way, this service supports Azure Lighthouse. So if you're managing subscriptions and resources, customers have delegated to you, so it does, you can use that. The next aspect in terms of how Sentinel deals with the MITRE attack, in terms of how it deals with the MITRE attack framework, is this concept of workbooks. Now, workbooks are common with Azure Monitor. And if any of you are, involved in doing deep dive monitoring and deep dive troubleshooting, I strongly suggest that you start using Azure Monitor if you've not used Azure Monitor. It's and particularly workbooks. So what workbooks are, it's based on the Custo language query, but you get much deeper insights, right? And you can start to see metrics that are far more advanced, and you can start correlate. You can start correlate data between different metrics if you're troubleshooting a performance issue, for example. And there's some out-of-the-box workbooks. Workbooks in Sentinel is there for monitoring, so you can monitor the data that's coming in that you just connected using workbooks. And there are some custom workbooks, for example, if you want to monitor Azure Activity, Azure AD audit logs, Azure Firewall, DNS. Just give me a second. Right. And Azure Sentinel allows you to create custom workbooks across your data. And it comes with built-in workbooks that I will show you now once I get into the portal. So we've now connected our data. We now have our workbooks to monitor the data. We now want to, we want to go into the analytics side of things. Now, remember what I said about why Sentinel is a solution that you want to look at from a SIEM perspective and cloud SIEM perspective, is the reduction of noise. The reduction of noise and minimizing alerts. Remember, alerts, the concept of, let me just explain this. What is the difference between an event, an alert, and an incident in Sentinel, right? Normally, we associate alerts coming through or events coming through from any activity in the event log. So in the Sentinel world, an event is a description, or it's a single occurrence of the thing that you're monitoring. For example, a single entity is a log file that could, if I'm monitoring the activity log or Azure activity log, if someone accesses the log, that's an event triggered. An alert is a collection of events that are taken together, right? And these are significant. So an event is not necessarily something to be concerned about. And that's why Sentinel doesn't just necessarily respond to events that happen. But an alert is a collection of events. Now you're seeing, hang on a sec, you're seeing these events, somebody accessed a storage account. Now that's not strange, or someone changed, or someone's trying to query for the credentials or the keys of the storage account. But if you see that event coming through, sequentially, now that's significant from a security standpoint. An alert could contain a single event if that event had significant security ramifications or implications. And that could be, for example, an administrator login from a foreign country outside of office hours, for example. So even though events are not necessarily untoward, it's the type of event that you need to be paying attention to. And this is where Sentinel, it can classify and it can help you then take action or run a playbook against it. So we have an event, we have an alert, and then what are incidents? You may ask, okay, how do I distinguish what are incidents? So Azure Sentinel's internal logic will create incidents from alerts or groups of alerts. So if it sees a pattern of kind of suspicious activities, if you take a look at the screen there, then an incident is created. And Azure Sentinel ingests raw events from data sources, and then it will generate an incident, and that's something you need to take seriously. So what do we have? We have connecting your data. This is fairly easy to do, guys. Connecting your Azure Sentinel to the Log Analytics workspace. There's pre-built workbooks for most of the Microsoft technologies that are available. And analyzing also is built on, and it depends on what you're wanting to monitor. Based on what you're wanting to monitor in Azure Activity, for example, there are built-in capabilities for you to be alerted on. So the next aspect about security monitoring, right, is the ability to take action. And this is where Azure Sentinel is no longer just it's just an event alert management. It now switches into security and orchestration, which is a SOAR standard. And you can automate the events that are coming in. The incidents that are coming in can now be automated using Azure Logic Apps. So for those of you who are developers, you can use Logic Apps in a very structured manner. It's very componentized, and you can take whatever action that you want to take. For example, you want to take multiple actions, right? First action, log an incident with my ServiceNow or log an incident with my Manage Engine. Second action, invoke, second action, potentially block the IP. So if you're seeing an event coming in that you are seeing outbound traffic from your resources, then it's very possible that data exfiltration on that system has been compromised. Azure Sentinel, you can go in and you can block automatically. You can block that IP. And I'll talk about threat intelligence and how does it know it's a malicious IP shortly. So you can block the user IB logger ticketing system. Okay, so now we get into the fun part, and this is really for security analysts, right? You want to now start investigating, currently in preview, Azure's deep investigation tools. The purpose of this is for you to understand the scope of the damage, the blast radius. You often associate blast radiuses with explosions, right? How far has that explosion kind of reach, and what damage could an explosion do? And the investigation tools help you find the root cause. And it's very important that, especially in financial institutions, they have dedicated teams that do this, because you want to find root cause, because you want to know, where did this attack come from? What was the patterns of the attack? What was the chronological set of events for this attack? And you'll see what happens is you can draw a timeline. And with Azure, with investigations, what you can do is you can say, okay, I have an entity, and the entity is a user account, Contoso1. You want to see all correlated events for this. And with investigations, you start to visually see the lateral movement. Remember I spoke about lateral movement? You can start, if an attacker got in and he planted some code on different machines, and the logs are being collected by Sentinel, you will be able to see the footprints and the fingerprints of this individual and their techniques that were used and which account was compromised. And that's really very important. And it takes and this is where the raw logs that are coming through start to get visualized. And it's very simple to see. It's very simple to visualize. You don't really need to be a security analyst to actually see this. And that's the beauty of Azure Sentinel, right? This concept of hunting. Now, hunting is basically, it's based on the MITRE framework that I spoke to you about. Those many things that I spoke to you about previously. And it enables an organization to be on the front foot. Right? So hunting in Azure Sentinel allows an organization to be on the front foot and to proactively hunt for security threats across your organization before an alert is triggered. And that's quite interesting, right? So Azure Sentinel allows you to take action before something is detected. Because remember, when something is detected by any typical tool, it's more than often that the attacker has spent some time in your organization. And with using hunting, you can start to see whether someone's trying to enumerate a storage account, for example. You can start to see the early patterns of someone trying to gain control or gain initial access. And after you discover which hunting query provides the highest value, you can create custom rules based on that query, and then you can surface those as insights, as alerts, and then you move from alerts into incidents. You can also, by using hunting, you don't need to depend on the custom alerts that are created, the custom incidents that are generated by the custom templates. You can get even more granular, and you can close the door very early in that whole process by you being proactive. And even when someone, for example, when the Azure firewall sees maybe sees a certain number of alerts coming through from a strange IP address, whatever that IP address is, then you can initiate actions earlier than you would as if you waited at a later stage. You can see there that that's a Custo language, right? And this is the beauty of Thomas mentioned this. This whole engine is ultimately based on the Custo query language, which means there's consistency from performance monitoring. There's consistency going into Arc. There's now consistency going into Azure Sentinel. And what you can do with hunting as well, you can create bookmarks for interesting events, enabling you to return to them later. That's pretty cool. Now, before we go into the Azure portal, the beauty of Azure Sentinel is the fact that it's community-based. And there are workbooks and playbooks and hunting queries all posted in the community. And I mean, sharing is caring. And a lot of that is available for you. If you're developing something, and if you developed a new playbook to mitigate a particular threat, you can share that with the community. And there are some very, very talented security analysts globally that are posting stuff. So make sure you catch that. Let me switch on to the Azure portal to show you. Second. Okay. Now, this is so how do you onboard? So you've got your Azure environment, you've got your resources set up, and one of the first things you need to have in place, right? There's a prerequisite. You need to have your log analytics workspaces, and your log analytics workspaces is needed for nearly every sort of monitoring or security analysis tools, right? Even Security Center uses log analytics. So your log analytics workspace is, when you have a virtual machine and you want to monitor, you got a couple of options. You could tell the virtual machine, send my logs to the storage account, send the logs to an event hub, or send the logs to a log analytics workspace. Now, when the logs are being collected in the log analytics workspace, then you have, for example, Azure Monitor kick in, but they all are dependent. They all use log analytics, right? All of these use log analytics. They just provide a richer insights into those logs. And with that in mind, the onboarding is fairly simple, right? So what you have to do is, technically, you're not creating another object. Technically, what you're doing is you're basically adding a log analytics workspace into Sentinel. So all you're doing is you're saying pass the logs that are being collected from this log analytics workspace and pass it on to Sentinel. And that's really the connection that happens at this stage, right? So let's go into the Sentinel workspace. Now, in the Sentinel workspace, as you can see, this is your cloud scene, right? And you have the components that I mentioned. You have the threat management, the incidents, the workbooks, the hunting, the notebooks, which I haven't covered yet, the entity behavior, and threat intelligence. So if we go to, let's look at analytics, for example, right? And so if you look at the rule templates, right, these are things that you can detect, if you want to detect. And these have been put together by some very clever folks at Microsoft and in the industry, things that you wouldn't necessarily be aware of. And if you want to take a look at this, you want to create a rule, you can go ahead and do that. So go and create the rule. Okay, and the rule templates, if you actually look at the rule templates, right, there are 4 types. 1, 2, 3, 4. There's 4 types of rules you can create from in terms of the templates, and some of these are such that you can actually see the code. Some of these are proprietary Microsoft, like the ML behavioral analytics. You can't really customize that. But these are ones that is obviously proprietary to Microsoft, but you can actually you can actually create an incident based on that. If you take a look at that, and then we have the data connectors. Remember what I spoke about is once you onboard your log analytics workspace, what sort of data do you want to collect? Now, this list keeps growing on a regular basis. As you can see, it's important for you. You're not automatically going to start to see data visualized based on the sources. You have to plug in the data connectors. And I've currently got the Azure Activity connector in place. Let's look at the Azure Firewall connector, right? And basically, you have to have these. There's a couple of things you need to remember. If you want to enable these services in Azure have to be sending their logs to this log analytics workspace, right? Open the connector page, and you can see it's going to give you recommendations in order to do that. You have to send your logs to log analytics. If you're not sending your logs to the log analytics workspace, you can do the data connector, but it's not going to comply really because it's not going to see that data. It's not going to have line of sight. It's not going to have line of sight of that data. Azure Security Center. For those of you that uses Azure Security Center, I've got this connected. So Azure Security Center is obviously the security best practice SaaS solution by Microsoft. And what this does, now when you connect the Azure Security Center level of data coming through from Security Center and the best practices, it now gets augmented with the machine learning capability that comes through. And take a look at this, right? These are no Microsoft technologies. Checkpoint, Cisco ASA, Cisco Analytics, Citrix. These are external technologies. But let's take a look at the Cisco ASA. Right. So what happens is you then get instructions of how to pass those syslogs into the Sentinel, into the log analytics workspace. And remember, syslog is a standard logging framework and it's been around in the Linux world, the Unix world, for a long time. And if anything supports the syslog format and you want to capture those logs, well, pretty much send those logs into the log analytics workspace, send it through to the REST API. Also, another common event format doesn't need to be a log analytics. It doesn't need to be a syslog event format. You can collect logs based on the CEF format. And like I said, this list grows on a regular basis. Now, why is it important? Why is it important for a security analyst or an organization not to trust, for example, one piece of technology in the organization? Why is it important to maybe gather the logs of your antivirus? Why is it important to get the logs of the FortiGate firewall? Why is it important to get the logs of your proxy server? Why is it important to get the logs of your audit logs? If you don't have a multi-dimensional set of logs coming through, then you're not going to see the patterns when the security analyst is analyzing the data that's coming through or the incidents that have been generated. And if you want to do entity behavior, for example, entity behavior is predicated on the fact that it picks out an entity. It could be the entity being a username or UPN name, lawrence@xyz.com. And it's able to then, because all the logs are coming through from multiple places, it's able to correlate how or profile this entity. Could it be a system or it be a user? It profiles that user. But important that, and I see a lot of organizations now collecting logs from multiple devices and multiple endpoints. Just a word of caution, the way the pricing actually works. So log analytics, so Azure Monitor, combines Azure Log Analytics, Azure App Insights, and metrics and alerts. Those are the three high-level components of Azure Monitor from a pricing perspective. Azure Monitor, from a feature set perspective, you don't really pay for that, but you pay for the amount of logs that you're ingesting and the amount of logs that you are retaining, right? Now, Sentinel will also charge you for the amount of logs that you are retaining and the amount of logs that you're ingesting, because those are the logs that you are analyzing. Just ensure that you keep tabs. You keep tabs on the amount of logs that you're ingesting, whether or not you have Sentinel configured. If you turn on too many solutions, and if you turn on and particularly if you have redundant services like wire data, for example, you can be sending redundant data from an endpoint. But with the Sentinel, the way to mitigate that cost, firstly, determine what is legitimate logs you want to send, right? That's very important. What are the legitimate solutions you want to apply to your log analytics workspace? So make sure that your log analytics workspace is monitoring, has got solutions in there that you have set for key pieces of data that you want to, key pieces of information that you want to visualize, put it that way. And once you have validated that you're collecting the correct logs and you want to reduce your costs, then you look at reserved capacity. So you purchase reserved capacity from Microsoft, and basically what then happens, and you can get discounts on it. So for every 100 gig that you're ingesting, if you purchase 100 gig reserve capacity, you get, let's take a look at that. So if you take a look there, so this is Sentinel pricing, right? Azure Monitor pricing operates the same way. Now, for those of you who are playing with this and testing it, you're never going to reach 100 gig a day. But for corporates and enterprises, it's very easy to get to 100 gig a day. And if you want to get a 50% over pay as you go, you purchase a reserve capacity on Azure Monitor and Azure Sentinel, and then your costs reduce. And this is one way to ensure that you're maintaining a practical seam. Because the last thing you want is you don't want to be ingesting more data than you should. And that's important to pay attention to. So coming back to workbooks. Now, what workbooks are actually the monitoring views, right? So the difference between what you want to be alerted on with the incidents and versus what you want to monitor. So if I view this template, I don't have any data. Ironically enough, I selected AWS user activities. Notice that this looks like Azure Monitor. So if I go back to workbooks, let's just take Azure. I've got the green line there, which means I've actually deployed that view saved workbook. So this is a workbook. You can start to see data coming through. You notice that this is an entity in your search query, in your Crystal language search query, and you can start to see data coming through. Now, the beauty or the purpose of these workbooks is that it's visualizing, it's making sense of the raw data, right, that you are collecting. And if I go back into the saved workbook, I want to see the Crystal query on it. You edit it. Let's just say edit. And you start to see that ultimately behind the scenes, it's a log analytics Crystal query. So there's consistency, on it. For those of you who are, for those of you who work in enterprises and you want to develop skill, human talent and talent within your organization, one of the key areas that a lot of organizations don't focus on, especially when you are managing the cloud, is automation. I think automation in terms of Azure automation and ARM templates, and also there's another level of automation. I call it automation, but it's actually skill within your organization to be able to query data like this. This is human readable, as you can see. So you don't need to be a developer to start to make use of this. And the beauty of this, all of this, is just that language. So now let's look at, remember what I said about the playbooks, right? So the playbooks are Azure Logic Apps. And what playbooks are, it's you've created an incident and the system has detected a bunch of alerts coming through. It's packaged that into alerts. It generated an incident. And now you wanted to take action, right? Maybe your team is asleep, and what you do ultimately is you integrate Azure Logic Apps with Sentinel. And you can take action when a response to an alert, Azure alert is triggered, preview, new step. Right, I'm not going to get into too much detail on this, but you can see to what level you can take threat mitigation. So, I mean, like I said, you could block the IP if it is coming from a known IP address. And once again, you don't need to be a developer to work with Logic Apps, so that's great. Okay, so in an organization, typically you'd have these security playbooks, and these playbooks are, some of them are available in the community. What I want to talk about is, remember I spoke about hunting, right? Hunting being a proactive technique. You haven't yet been compromised, but someone's in your organization, or someone's trying to get into your organization, and the you know what I spoke to you guys about in terms of initial access, execution, persistence, privilege escalation, defense evasion, credential access, discovery. These are things going to leave footprints inside your organization. And what a hunter will come in and do, or security analyst now, is going to go in and interrogate. Right. This hunter will go in and he's going to see, for example, I keep bringing this up, but because this is a really good one, right? Someone's trying to enumerate your storage keys to try to get in. Ultimately, they might get in, but you want to know of something that happens before it happens. And this is where a hunter, security analyst, will come in, and he'll use the different disciplines in the MITRE ATT&CK framework to be able to determine whether an incident's about to occur, or whether there's someone attempting something inside the organization or outside the organization. And remember, these are logs coming from multiple sources, right? I mean, and this is the amazing part of these capabilities that you have at your disposal. You don't need to now go and say, give me all the firewall logs at that point in time. You query the logs real time because the logs are already coming into your organization. And what else do I need to cover? Very, very important. So if we look at notebooks, so notebooks are, I'm not going to spend too much time on notebooks because this is a Jupyter notebook, and these are guys who you want to now go in and as almost like a data scientist. I want to use like a word as a data scientist. This is tools that a data scientist will use. And then you can go in now and you're not kind of satisfied with what you're seeing, but you want to go in and using machine learning models. You want to go in and start, analyzing the data, the patterns, the logs, and it's all consistent, right? It uses Microsoft Azure machine learning, but what's happened here, there's tight integration now with Azure Sentinel. And this is a typical Jupyter notebook. So as you can see, there's a science to it. But the tools are there. If you're willing to go down to that level of detail. I know my time's about up, and I just want to talk about two more things, and that is something called entity behavior. So I've got this configured, right? You don't necessarily see the onboarding here, but entity behavior is actually quite interesting. It's about identifying threats inside your organization and the potential impact. Whether it's a compromised system or whether it's a malicious insider. I mean, that's always been time consuming and labor intensive. Even the tasks that I'm showing you now, I mean, there's some effort to it, right? Is there another way that there's some level of profiling that can happen? Profiling meaning that the system has built up a level of this pattern is common with this user and this pattern is common with this entity. Anything else is going to be an anomaly, right? That's the logical. That's how entity behavior actually works. It knows and it'll build up a pattern of what is common for a system, a user account, or whatever. And this technology is very useful in dealing with like zero-day targeted and very advanced threats. And what it does is it almost eliminates the drudgery from a security analyst workload, and it eliminates the uncertainty, right? The uncertainty from their efforts. And what it actually does, it delivers extremely high fidelity, actionable intelligence because it's machine learning driven. There's no human interaction in UEBA. And as the logs come in from all of its connected sources, it analyzes them and it builds baseline behavioral profiles of your organizations. Entities, what are entities? Entities can be hosts, users, IP addresses, applications, and they can be, it can be across time, it can be whatever. What this does is it builds a profile of those entities. And if anything is outside the norm, it's an anomaly. And then it can flow into the sequence of now creating an incident and creating an event and a set of alerts, and then creating an incident, then taking action later. Finally, threat intelligence. So threat intelligence is cyber threat intelligence is information describing known or existing potential threats to system and users. And this can be a global thing. Microsoft has its own cyber threat intelligence organization, and a lot of the Microsoft technology tools and advanced threat protection tools from Microsoft actually plug into, for example, how does it know that something is a known IP address that it can, and one of the might attack frameworks is being able to know, okay, it doesn't matter how sophisticated an attacker is, if they're coming from a known IP address or they're coming from a known location, if you've got threat intelligence plugged into your Sentinel or whatever tools you're using, you can kill them at that kill chain, right at that point. And for organizations, it's almost like the first door into organize to block out IP addresses known to be malicious. This can be IP addresses, domains, file hashes. If it detects a file hash on one of your servers, right? Then obviously it's a pattern, and it came from a specific. It came from a known entity that's associated with that file hash, and you can almost assume that you've been compromised. What threat what it actually does is it uses a thing called so if you had a new threat type, if you take a look there, it's based on threat indicators. Now, threat indicators are data that associated URLs, file hashes, IP addresses with known phishing attacks, botnets, or malware. And that's why it's important to have some sort of threat intelligence. A lot of the Microsoft Azure technologies, like Azure Firewall, for example, even Azure Application Gateway has got threat intelligence capability. Finally, I just want to point out the community. Right. So if you want to start off with Sentinel, get on GitHub, go to the Azure Sentinel community, register, and share. And as you can see, there's some very useful playbooks, templates that are very useful in notebooks that have been created, workbooks that have been created, so you can get off the mark. Security doesn't need to be something you need to learn. It's something that you can build upon and you can improve. That's what it's about. You shouldn't be learning from your own mistakes or from others' mistakes. You should be learning from their mistakes, and don't make the same mistakes is what I'm essentially saying. Learn rather than make the same mistakes. And by sharing and being plugged into the community, you can use what they've developed, you can improve what they've developed, you can share with them, and you can keep your customers and your organizations safe. With that, that's a wrap.
Hello?
Hi.
Oh, Lawrence, that was a great session. Thank you so much. I really love it. And I can see there are some questions in the chat box. I don't know if you can answer them before.
Let me just go there.
Yeah.
Okay, it's got a few questions here. The amount of data goes into could be quite, yes. I see Ronald made a comment there. So Ronald and I work together. So the data stays within Ronald, as far as I'm aware. The data stays within Log Analytics, and secure with Azure Sentinel. You're paying for the analysis. You're paying for the analysis. You're paying for the analysis of the data and the retention of that data. So you can only delete the data from Log Analytics. That's the ultimate score. We have a custom application in Azure Functions, which has log analytics configured on top of it. We have a lot of debugging logs being generated, end up being sent to log analytics. This debug logs can be quite expensive. Absolutely. For those of you on the call, it's very important to know. It's very important to know which log collection tool to use. If you're developing like .NET applications, and rather use like application insights, because application insights like Azure Monitor will give you application insights. Well, just exactly what the name means. Whereas Azure Monitor will give you VM insights, container insights. So it's very important. Use the log collection tool. But log collection, if you get it wrong, can be a very expensive exercise. So you've got to be quite intelligent about it. Please come again on the playbook. Okay. Basically, playbooks are automated responses to threats that have been detected or incidents that have been created, which means that if you're monitoring suspicious activity, multiple alerts were generated because someone's doing something that's out of the norm, and an incident is created, and you want to take action immediately and not wait for a human to get to that incident in Sentinel. So you can create a playbook, which is essentially a logic app in Azure. And a playbook is a collection of procedures that can be run from Azure Sentinel in response to an alert. And it basically is there to automate and orchestrate your response. It can be run manually if you need it to, or it can be triggered automatically when specific alerts are triggered. I must tell you guys that you must actually test it. I'll give you a scenario, right? When an alert is triggered, it can open a ticket in ServiceNow or any other ticketing system. You can then send a message to your security operations channel in Microsoft Teams or Slack, whichever one you want. Send all the information in the alert to your senior network admin, security admin, the email message. The playbook could also continues to run after the response is received. And then you could actually, if the admins choose, right, based on an approval, to block the IP address. So you don't just block the IP address. That's what a playbook is. Ernest, did you get that?
Yeah, I'm clear now. I'm clear
Cool.
now. Yeah.
Are there any other questions?
Hi, Lawrence.
Hi.
Sorry, I can see that the log is being priced by storage size. What I mean is it's being priced daily. I've seen something like 100 gig per day.
Yes.
So does it mean, for instance, if you have important alert coming after 100 threshold that have been reached, those logs will not be set for you?
No. Unless you set a cap on your log analytics. So unless you set it to not go beyond a certain amount of log ingestion per day, it will continue, but you're going to pay for it. If you set a cap, it's going to drop traffic.
Okay.
It's going to block log ingestion.
Thank you.
Lawrence?
Yes.
Yeah, I think for now, you have to be in the chat. If you can reply some of the questions there, that'll be fine. Okay, thank you so much. We are really happy.
Pleasure. Thanks, guys.
Okay, we are going to welcome the next speaker. Steve, are you around?
I'm here. Can you hear me?
Oh yeah, that's great. Awesome.
Okay, perfect. I can go ahead and share my screen. All right. Let me know when you can see my screen.
We can see it now.
Okay, perfect. All right. Was there anything you needed to say before I get started, or should I go ahead and get started?
Hello?
Yep. Should I go ahead and get started, or was there anything you need to cover before I get started?
We wanted you to introduce yourself through the video.
Okay. Yeah, sounds good. So thanks everyone thanks for having me be a part of the user group. Really excited about this. Um, I wish I could actually be there in Ghana in person to meet all of you. And actually, I have some ancestry back in Ghana, so through some of the DNA testing, found out
Yes,
that
still we can't see you on the video.
oh, let me share a video here. All right, can you see me now? It's dark here. It's like 6 in the morning, so
Okay.
yep. So yeah, but I'm really excited to be a part of this user group, and like I said, Ghana is somewhere I definitely want to visit sometime in the near future. So let me go ahead and do my official introduction here. So that's a summary of me. So I'm based in the United States. I'm based in a state, Minnesota. You might have heard of it if you've heard of music from Prince or recent events. You might have seen the stuff that happened with George Floyd. So yeah, I'm in the northern part of the U.S. I work for a company called Avanade, which we are the Microsoft arm of Accenture, essentially. And Accenture is global, right? I'm a part of the cloud transformation team with Avanade, and I do a lot of Azure projects and a lot of DevOps, so container work, things like that, working with Kubernetes. I've been a Microsoft MVP for 9 years, so I'm in my 9th year and hoping for number 10. We'll see what happens. Also, I'm the author of 6 books. So my latest books are Azure Kubernetes Service, and the one before that was around Azure Stack Hub. So if you're looking into those technologies, check those out. And you can certainly follow me or stay in touch at Bukatech on Twitter. So that has a link to my blog, and I'm pretty active out there. Also, I'm on Pluralsight, so if you're looking to learn stuff about Azure or other technologies, I'm always publishing stuff out there. So let's go ahead and jump into the slide, and I'm actually going to stop sharing my video just so it's less distracting. But this is what we're going to talk about in my session. So we're going to dive into Terraform, and I'm going to give everyone.
Steve.
Yep.
Hello, Steve. Yeah. We wanted to be clear about your DNA results. You have any connection with which African country?
Ghana.
Oh, Ghana.
Yeah.
Whoa, we are happy to hear that.
Yeah.
We really, after this session, we really need to talk.
Yes, we do.
Okay.
Yeah, so I through my ancestors, I have some roots that trace back to Ghana. So that's another reason I'm really excited to be presenting to this user group today. So, all right. So as a part of the session, we're going to dive into Terraform. So I'm going to give some background on what Terraform is, and then we're going to dive into how to use Terraform with Azure specifically. Right, and then we'll finish off with an actual demo, and I'll show you how to deploy some networking components in Azure using Terraform, and I'll also show you how to deploy an actual Azure Kubernetes service cluster. So let's dive right in here. So Terraform is an open source product built by HashiCorp. So you can download this today. You can start working with it. And you can actually use it not just on Azure, but you can use it across multiple clouds. You could also use it for other products. So let's say if you're running Azure and maybe you're doing stuff with MySQL, or Kubernetes is a perfect example, and you want to do some automation against MySQL, Kubernetes, as well as Azure, you can use Terraform to do automation against all three of those different technologies. So Terraform's main use is basically to provision infrastructure. That's mostly what people use it for, and mostly infrastructure in clouds. You also could use it to automate against things like VMware. So if you're using VMware on premises, you can certainly use it for that. And if you're using, something like AWS or GCP, or you're doing multi-cloud, you could use it to help automate against those things. And then also you can use Azure Arc. This is a plug back to Thomas's session, right? To bring the Azure management plane to workloads running in those other clouds. So Terraform is basically infrastructure as code. And I think there's a misconception out there sometimes where folks think of Terraform as configuration as code. There's a difference between infrastructure as code and configuration as code. And IAC is about deploying the actual architecture. So think of things like your networking, your storage, the actual, virtual machines themselves. And then configuration as code is like, okay, I have these virtual machines, or I have this Kubernetes cluster, and I have these, containers running on this Kubernetes cluster, aka pods. And I want to configure these things, right? I want to configure my virtual machines so that they're ready for me to install my software. And maybe I'm even going to use my configuration as code solution to actually install the software. So things that are typically configuration as code are like Ansible, or in the Microsoft world, right, DSC, Chef, Puppet, etc. Those are things that we typically use to automate on the actual machines themselves. And then in the container world, right, with Kubernetes, that's a whole nother animal, right? We use like config maps right inside of Kubernetes to go ahead and do that. So when you're looking at Terraform, you're comparing it to other products, make sure you're comparing apples to apples and not apples to oranges, right? So you want to look at like, okay, how does Terraform stack up against like ARM templates, CloudFormation templates, things like Pulumi, and that's where you want to do that comparison, and that's where Terraform really lives. And so in the Azure world, we're looking at Terraform and we're looking at ARM templates, right? And ARM templates are the native way in Azure to do infrastructure as code. So why would I use Terraform, right? Well, the obvious one is multi-cloud, it's multi-vendor. So if you're using Azure, if you're using AWS, GCP, maybe something else on premises like VMware, or even Hyper-V, you could use Terraform and use one language, one framework, and go ahead and build your automation against, all of those different things. Now, keep in mind, and this is another misconception out there, that when you're using Terraform across multiple clouds, you will have scripts that are different across those multiple clouds, right? So your Terraform scripts that you've written for Azure are going to be different than your Terraform scripts that you have for AWS. And that's simply because they're using different APIs. There's some underlying differences between, those different cloud providers. And the same goes for multiple vendors as well. The next one is it's declarative versus imperative, right? If we talk about imperative, something like PowerShell, where we have to, explicitly spell out like all of the steps of what we're trying to do. With Terraform, you basically code, what you want the state to look like, and then you tell it to go, and it makes it happen for you. Terraform tends to be faster than a lot of your native automation. I don't know why, but it's definitely interacting directly with the API. So like Azure Resource Manager, and being able to apply changes with confidence. So there's a separation between executing and planning, and what that means is you can go ahead and say, if I run this code, what's going to happen? And Terraform will actually show you what might be changed, what might be deleted, what might be created that might be new. So you can actually run a Terraform plan before you actually do the Terraform apply, which will make the changes happen in your actual environment. So that gives you a chance to catch if something might happen that might be bad for your environment. You can catch it right then and there, and then not run the apply and make further changes as needed to your code. So I know with ARM templates and with PowerShell, there's like a what if now, so you can sort of do a similar thing there too, which is cool. And also Microsoft has a new language called Bicep, which is really cool, and it's declarative as well. That sits on top of ARM. And so if you want to stay within the native kind of landscape for Azure, you can do that using Bicep and ARM templates. And so there's some really good stuff coming from Microsoft to help with the whole infrastructure as code story. Also, I want to just call out that there's absolutely nothing wrong with using ARM templates. Depending on the project that I'm working on, sometimes we'll go pure native ARM templates, and sometimes we'll use all Terraform. It just kind of depends on the preference and what's happening with that project and what the requirements are, right? But I am seeing more and more that, hey, we're using Terraform. All right, some of the Terraform components, I'm going to lay these out here. Now, there's much more to Terraform, and I will say the Terraform documentation is pretty awesome. So if you get a chance, pop out there on the Terraform or the HashiCorp site and check out the documentation. Also, Microsoft actually has some really awesome documentation for Terraform that makes getting started with Terraform on Azure really easy to do. So, all right, so the first thing we have in Terraform is we have resources, and resources are basically the things that you're going to create. So in the terms of Azure, these are things like, virtual machines or VNets, or, I'm going to create this SQL database. And so you have these resources in your code, and Terraform is going to go ahead and create those resources. The next one I want to call out is, and I don't know if you can see my mouse, but data sources, right? And data sources is basically, if you have some existing, resources in your environment, you need to pull some data back because you're going to use that data. Think of like subscription IDs, think of like maybe a DNS name, or, what have you, IP addresses, because you might be using that in your code. You can use those data sources. And so you can pull that data back and work with it within Terraform. Jumping back up to the first line here, providers is another component of Terraform. And what a provider is Terraform has built all these providers to automate against your different environments and products. And so a provider is basically your way of connecting Terraform to a service. So for Azure, for instance, there exists a Terraform provider for Azure. If we're going to automate against Kubernetes, there's a provider for Kubernetes. If we're going to automate against something like Docker or maybe even MySQL, there's a provider for those. And so what you'll have is you'll have your Terraform script, and you'll have your providers in there of the services or multi-clouds that you're going to automate against, and the provider is how you communicate with those services, and it's basically communicating with the underlying API of that service or that product. And then we have something called provisioners. This is actually pretty cool. What you can do is you can have Terraform like kick off additional scripts. So earlier I talked about the difference between infrastructure as code and configuration as code, and things like Chef or Puppet would be configuration as code. So you could have, your Chef, I don't know what they call them, cookbooks, built out, and you could have your Terraform code run and then kick off the Chef cookbook to go ahead and configure the VMs, right, after Terraform has deployed those VMs. And then we have input variables. I'm not going to even touch on that. Pretty standard across scripting languages. But if you need to, have different variables in your code, you can use that. And then output variables. So if you need to provision something, and I'm actually going to show this in the demo, well, actually in the code, and I'll show you the output variables or output values and how that can be used. But basically, when you provision something, maybe you want the output of that, so you can see it on the screen, or maybe you're going to use it later in your code, right? And then you have modules. Think of those as like functions. So something that you need to do in a repeated manner, you can go ahead and use those modules. So you don't have to rewrite the code over and over and over and over. And then configurations. So basically, it just describes your desired state. And you'll see that like the code of Terraform are configurations. And then a big one is the Terraform state. And so what happens is when you deploy things and provision things with Terraform, it's actually creating a state, and it's using the state. So it's keeping a record of, what you've deployed, what exists in your environment. And so it's really helpful. And so when you go to run a Terraform plan and you're going to change something in your environment, it looks at the state and it is able to tell you what's there, what's not there, what it's going to delete, what it's going to add. And it's doing all of that because it's pulling it from the state. Now, the Terraform state is something that you need to store somewhere. And by default, it's going to store it locally. So if you're running Terraform from your machine, it's going to store that state locally on your machine. When you're doing Terraform in production, you don't want to do that. You want to have that Terraform state stored somewhere. And I'm going to talk about that in more detail in a couple of slides. But there's something called backends. So, and this is basically a way you can store your Terraform state, or you can, specify where you want the Terraform code to be executed. So Terraform actually has a cloud offering where you can actually run, like, I think it's called Terraform Cloud, or it might be Terraform Enterprise at this point. They keep changing the name. But you could actually have your code, your Terraform code, live there, run from there. That way you don't have to have your computer on while this Terraform code is running, right? You can just run it from there and then walk away and let that automation happen. All right. So Terraform workflow. This is actually really straightforward, right? So after we've built our Terraform code and we're feeling good and we're ready to go ahead and run that against an environment, then we want to work through the workflow. So we have something called Terraform init, and this is typically the first one that you're going to run. Now, these are syntax here. So these are, and I'll actually show you that when we get into the demo. But these are commands that you will actually run as a part of the workflow. So Terraform init is actually going to make sure that you have the right providers. So you've listed the providers that you're going to use in your code. And when you run Terraform init, it's going to go ahead and process your code and make sure to download any files and stuff that's needed for the providers that you're using, right? So this is kind of the first step. And so Terraform is typically stored in a directory. And so when you run this Terraform in it, it's going to populate what's needed in that directory to go ahead and basically use Terraform. Also, it's going to look and see, have you specified to use a backend for the state? And if it does, then it will process that. If you haven't, then it will actually create that state file locally. And we'll talk about that shortly. And then the next step is you want to run Terraform plan, and Terraform plan will actually output what's going to happen in this environment. Like, what are we going to create? What are we going to change? What are we going to, what's going to be deleted by this code? So it's super helpful. And then when you're ready to actually do the things, right, do the automation, you'll run Terraform apply, and it will actually deploy the stuff in your environment. It will actually make it happen in your environment. And then Terraform destroy does exactly what, it says, right? It's going to delete everything. So it's going to look at your state and it's going to delete everything that's basically in that state. So use this with a huge amount of caution. And the Terraform destroy, we typically don't use that in production, right? We typically only use this in like demo environments. I don't even use this in like dev environments that teams are actually using because it's risky, right? You don't want to blow away an entire environment that people are depending on. So, all right, next up. So here's just an example of Terraform configuration. So remember in the components, I talked about Terraform configuration. So with your Terraform, you have basically two types of files. You have a .tf file, and then you also have a .tfvars file. So the TF file is basically your Terraform scripts. The TFVars is your default extension for files that might have variables in those files. So what happens when you run Terraform plan and Terraform apply is it looks in the folder that it's running in, and any file that has a .tf, Terraform is going to process that. And so, if you have files in there that you don't want Terraform to process, you'll rename the end of those files with .ignore or something like that, right? And then Terraform will ignore those files. Otherwise, it's going to process those files. It thinks that you want to, do whatever's in those files. And so you just want to keep that in mind. And here's an example of just the Terraform code for Azure. And so this is actually old. You'll see kind of an updated code when I actually show you the demo in my VS Code. But basically, you specify the provider you're going to use, and then here you can see, we're starting to create a resource group. So here's the name of my resource group. Here's the location, and you can clearly see that I'm pulling the location from a variable. And so that's one of the nice things about Terraform too, is you specify the variables either in another file, or you can even do it in your .tf file, and then you just reuse that throughout your code. And then, we're tagging that. So it's going to tag that resource group. And then here we're creating a VNet inside of Azure. And so, here's the name of that VNet. Here's our address space. Again, we're using a variable for the location. And then with the resource group, and again, I'll show you all this in like real code, so it's a little bit easier to see. But we're pulling the resource group name from this previous block of code here. All right. So here's an example of Terraform plan. And again, I'm going to show you this live in the demo too. It's kind of nice to see this stuff on slides just in case maybe the demo blows up. Hopefully it doesn't, fingers crossed on that. But when you run a Terraform plan, it basically gives you this output, and you can clearly see here that it's going to create an availability set. And here's what it's going to create, and here are the details there. Down here, it's going to create a managed disk, and here's what it's going to do for the managed disk. So location, central US, right? Here's the name, disk size, et cetera, et cetera. So this is really nice because you can output this, you can see what's going to happen. And so when we talk about things like documentation as code, this is, getting us closer to that. All right, let's talk about Terraform state. So the Terraform state, again, is going to be in a file that ends in .tf state. And this is keeping track of your state of your environment that was created by Terraform. So you can either have, like I said before, you can either have the state stored locally, which is the default behavior of Terraform, or you can have the state stored somewhere else. So that would be stored remote. And we can actually store state on Azure storage. So you can just spin up some blob storage. You got to get the storage account, the storage key, and then you can specify that stuff inside of your Terraform. Or if you're fancy and you're doing things through Azure DevOps, like a pipeline, you can tokenize things. You can use variables in there and call that stuff from within your Terraform scripts. And that's actually what you would want to do in production. And then what happens if you're storing your state on Azure, for example, as a backend, when you run your Terraform code, it's going to go out and connect to that Azure storage to look at the state. And when you're running this in production, or when you're using Terraform in production, you want to use something like that. Or maybe you're going to use Terraform Cloud, where you're going to store your state and things like your workspaces out there in Terraform Cloud, so you're not storing those things locally. And when you're working with a team of people that are doing automations on Terraform, you definitely want to have your state stored remotely. The other thing with the state is don't ever go in there and do anything manually, ever. Like, just don't do it. You can look at it if you're curious locally when you're learning about Terraform. If you open it up, it's just a bunch of JSON, so it's actually pretty easy to read. It's kind of cool to check out, but when you're running something or using Terraform in production, or even I would argue development, like, just leave the state alone and let Terraform manage that. So when you first run Terraform, it creates that state file. When you run the Terraform for the first time, it's going to populate that state file. When you run Terraform again, right, maybe you're doing an update, you're adding some things, you're changing some things in your environment, Terraform is doing a refresh of that state file. So it's going to go out and it's going to look at your Azure environment. It's going to compare what's in the state file with what's actually there. And if there are some changes, it'll tell you about that. But one principle is, if you start doing infrastructure as code, you want to keep doing infrastructure as code. So if you build your environment through infrastructure as code, you don't want to have people from your team out there logging into the portal, manually creating things, manually changing things, because then the state of the Terraform file and what's actually there will definitely get out of sync, and it can just be a management nightmare, right? Now, Terraform does have some options where you can tell it to go and get data from an environment and update a state, and you can certainly do that, but I've never done that in actual production, and I've heard that it can get pretty ugly pretty fast. Yeah, so that covers the state. So just moving on. So earlier I talked about providers in Terraform. So with Azure, we actually have a specific provider for Azure ARM. But there's many providers, right? So in one of the Terraform's configuration files that I'm going to show you, the Terraform scripts, it actually has a provider in there for, Azure, and then I have a provider in there for Kubernetes as well, because I'm using both to do different things, right? So the Terraform provider for Azure is what's going to connect to your Azure environment. And so with the provider, you need to authenticate to your Azure environment. So you can either, build out some variables with your authentication information. So things like your subscription ID, and basically, SPN information to connect to the environment. Or what I like to do is run things from Cloud Shell. And I'll talk about Cloud Shell. It's just a lot nicer, and you just need to specify your subscription if you have multiple, and then you can run it, and things are authenticated, and life is good, and Terraform runs like it should. The other option is if you're running Terraform from like Azure DevOps, and then you build your authentication in there, and that works pretty smooth as well. And so when you're running things, or when you're using Terraform against production, I'd recommend using Cloud Shell or using Azure DevOps. So the Terraform provider basically works with ARM, and it works directly with the ARM API. And I'm talking about this second box here. And so the provider works with most of the resources that are there in Azure, as well as data sources. And so these providers have to be updated. So with a provider, it knows how to interact with like virtual machines, AKS, Azure networking, things like Key Vault, Azure storage, et cetera, et cetera. Now, Microsoft is releasing new types of resources and services all the time in Azure. So when they update something in Azure, they're building it on top of that ARM control plane, right? Someone needs to go update the Terraform provider to basically tell it, hey, there's this new resource that exists in Azure, or this new service, and here's how you interact with it. So that responsibility falls on HashiCorp and Microsoft. So actually, HashiCorp will update many of the providers, and sometimes they work with the vendors. And in the case of Microsoft, Microsoft actually has some people on the product group team that work directly with Terraform, and they'll make sure that when something new comes down the pipe from Azure, like a new service is released, that they're interacting with HashiCorp and making sure that provider is updated. So when you or I are going to do some automations, and like there's a new service like Synapses or maybe Azure Arc or something like that, and we want to automate against that service, it's there, right? And it works in the provider. So it's really cool to see Microsoft and HashiCorp kind of work hand in hand like that, to make sure that the Terraform provider works on new services. Now, something I didn't mention about the providers earlier in Terraform is that you have providers that are built by HashiCorp and maintained by HashiCorp, and then sometimes in collaboration with the third-party vendor. For example, in the case of Azure, which is really cool. And you also have providers out there that are built by community folks, right? So folks like you could go build your own provider for something if Terraform, if it doesn't exist yet, right, in Terraform, you could build that for whatever service or software you want to automate against, and you could publish that out in the Terraform repository, and then others could use that. So there are other providers out there that are built by the community, which is kind of cool. So All right, moving on. So Cloud Shell. If you're not using Cloud Shell today, start right now. Like literally pull it up on your machine, like log into the Azure portal, hit the little command icon at the top of the menu bar in the Azure portal, open Cloud Shell and start using it today. Cloud Shell is amazing. Also, if you're using VS Code, you can use Cloud Shell in VS Code. Thomas Maurer actually has a blog out there and a video out there on how to use Cloud Shell with Azure. Cloud Shell is awesome because Cloud Shell has, well, actually, let me let me go through my points here. So Cloud Shell has a bunch of languages, frameworks already preloaded in it, right? So like Bash, PowerShell, Azure Command Line Interface, Ansible, Chef, Puppet, all those frameworks and languages are preloaded in there and they're updated, and that's all taken care of by Microsoft. So Microsoft maintains that. So if you think about using Cloud Shell versus having to load all of these languages and frameworks on your machine, it removes that overhead from you having to do that. So it's pretty amazing, and just one of the many benefits of cloud. Also, Microsoft has preloaded Terraform in Cloud Shell. So when Terraform releases a new version, Microsoft typically is pretty fast about updating the version that's available in Cloud Shell. So yeah, you can log into Cloud Shell with your Terraform scripts, and you can just run them from there. You don't have to load or configure Terraform or do anything with that. And to get to Cloud Shell, I described how you can get to it from the portal. You could also go to the shell.azure.com, and it's just Cloud Shell right there in the browser. It's pretty awesome. Or you can load it in VS Code and use it right from VS Code if you want to do that as well. So when you're working with Terraform in Cloud Shell, one thing that you need to remember, make sure you're setting your Azure subscription if you have multiple. Like me, I think I have like 4 different subscriptions in my MVP account that I use, right? And then when it comes to work and different projects, I have even more. And then I also have friends that will give me access to their subscriptions for collaborating on projects, community projects or demos. Like a good friend of mine, Sam Ernstein, we've worked on books and stuff together, and he'll give me access to a subscription to do stuff in there. And so you want to make sure that when you're working in there, you're setting the subscription. So when you go to run your Terraform, you're not like automating or creating in the wrong subscription and creating an unexpected expense, right? Also in Cloud Shell, you should create a folder. And then in that folder, you'll want to put your Terraform scripts in there. And you'll see that when I show you the demo. And then you'll work from those different folders. So, and then another thing with Terraform that's just important to note is that, at some point, you will end up running ARM templates. You will have the need to run ARM templates. It's just going to happen. There are services out there that aren't supported yet on Terraform for whatever reason, or you may be using a service that's brand new and it hasn't been updated in the Azure provider for Terraform yet. And so you may need to do that automation still. And so, when new services are onboarded to Azure, ARM templates work right away, right? And things like Azure Command Line Interface or Bicep. So Terraform has built the ability to go ahead and deploy ARM templates right from your Terraform code, which is pretty amazing, actually. And so when you get to this point on your Terraform journey where you're like, man, I can't automate against that thing because it's not supported in the Azure provider yet, don't worry, right? There's a resource for that, and it's basically this Azure RM resource group template deployment. And so what this actually does, I have an example of the code here. We're not going to demo this today, but it's basically a resource. And you go ahead and drop in the actual ARM template code right inside of your Terraform script, which is pretty cool because then you don't have to maintain like an ARM template JSON file and your Terraform script. You just maintain your Terraform script and your ARM template code is right in there. So then when you go to run your Terraform script, right, your Terraform space apply, it will process the Terraform code, and it's actually going to process the ARM template as well. So some pretty cool stuff. Pretty good collaboration between HashiCorp and Microsoft, and just, you know, all around, you know, well thought through. So that brings us to the end of the slides, and let's jump into a demo here. And what I'm going to do, I'm going to pull over my VS Code. So this is my VS Code here, and I'm actually going to pull over my browser too. And so the first thing that I'm going to do is I'm actually going to run the Kubernetes code here. So give me a second. So we need to go into the deploy AKS code or folder here. Oh, too fast. All right, there we go. We're in there. So now if we look in there, and by the way, I'm in Cloud Shell in one of my Azure subscriptions here. So let's go back to this tab. But so I have a folder here. It's called Deploy AKS. So, and what I have in here is I have my Terraform script, right, for deploying AKS. And let's actually, well, we'll kick this off in just a second. But I have my Terraform script for deploying my AKS cluster. You can see that I've already run it. I've already run like Terraform init. So I have my Terraform state file, and there's a backup for it as well. So what I can do here, since actually let me show you this. So if we run Terraform version, hopefully this works. This should output the version of Terraform that's preloaded in Cloud Shell here. And we'll give that a second here, and we'll change directories on this because this is going to be my second demo here. So I want to go into the deploy hub. In this directory, you can see I don't have a state file. So we're going to run Terraform init on that one. And this is not, okay, we're going to reset this. We're going to reset that Cloud Shell. And while we're waiting for that to happen, it looks like this one reset on me. So one thing about Cloud Shell is if you're inactive, it resets the Cloud Shell on you. So that's something you got to keep in mind as you're working through this. That if you're inactive for a while, like I've been on these demos, then it resets on you. But it'll come back. It actually saves your state, so like it still has my Terraform scripts and all my directories and stuff in there. So it's pretty cool from that perspective. And what it's actually doing under the hood is Cloud Shell is running as a container. So Microsoft basically, you know, preloads all of the stuff you need for Terraform in a container for you to use. So let's just see, we'll go into the hub. Okay, so there's my Terraform state there. Let's go back to this one. So cd deploy AKS. And we're actually just going to run this, okay? Terraform apply. So we're going to run that. And I will increase this. And while we're waiting for that one to start, we'll run the Terraform init over here. And this one's kicking off right away. So what it's doing is it's initializing the backend. I don't have a remote state specified in my Terraform file, so it's actually going to just generate that locally for me. It's going to download all the providers that I need as well. It's going to do that locally. And while we're waiting for those to run, I'm actually going to go through some of the code here. So I'm over in my my VS Code, and this is my Terraform scripts. So I actually have this AKS deploy and this hub deploy both uploaded to my Cloud Shell, and that's actually what I'm running from my Cloud Shell. So if we go through the code here, the nice thing about Terraform compared to just using pure like ARM templates is that you can drop in commands. I know you can do some comments, and I know you could do some comments now in ARM templates, but this is still very, very friendly. But if we look through here in my code, so what I'm doing here is I'm specifying the Azure provider, and you can see I don't have any authentication in here. And the reason why on this is because I don't need it, right? I'm going to run this from Cloud Shell, and so it's just going to, I'm already logged in, it's just going to work. And so if I keep scrolling down here, some of my code here, so I'm just going to generate a random name. So like I'm going to use this for naming my resource groups and naming my AKS cluster and naming like my VNet and things like that. And then this also has the other variables that I'm going to use. So I have a variable for, my location that I'm going to use. Here's the agent count that I want for, my node pool for my AKS cluster. Right, so I have some critical things there that I'm specifying in my variables, and SSH key and stuff that I'm going to use for log analytics. Right, so when I deploy my AKS cluster, I'm also deploying like log analytics, so I can have container monitoring right out of the gate. And then here I'm specifying my my resource group for my that I'm going to store everything in, right? And you can see that I'm using the random naming for my resource group, and I'm just going to tag or add to the end of it -rg, and you can see that I'm actually referencing the location here in that resource group from the variable as well. So you can see that we're starting to build on top of each things inside of the code here. And then when we get down here to the log analytics, this is where I'm deploying the log analytics that I'm going to use for my AKS cluster. So you can see that I'm specifying or referring to the resource group, and I'm referring to the location and the SKU that was all built in my variables here. And then giving it a name for the solution, or actually this is pulling the solution name, so container insights. This is pulling the location, and then down here is my actual AKS cluster. And so in my AKS cluster, I'm specifying the name, so I'm using that random name generator. I'm using the resource group from the that I created previously. I'm using random name generator for DNS, and I'm specifying a bunch of different properties that I need for my AKS cluster too. Like I'm using a managed identity. Here's my node pool. I'm tagging the environment, and where's my Cloud Shell? this. So I want to show you here, jumping back and forth here because my Cloud Shell is running a little bit slow. But so my my actual plan ran there. So what I'm going to do is a Terraform plan. And I think this is running a little bit slower because I'm actually sharing my screen. Oh, that ran faster. So thank goodness. So this is what a Terraform plan actually looks like. So I ran the Terraform plan and it's reading from my hub and spoke file. So it's telling me basically, hey, you're going to create all of these resources when you run a Terraform apply. Right. So let's go ahead and run the Terraform apply because it's probably going to take a little while, and then we'll jump back to the code. So when I run this Terraform apply, it's actually going to create 26 resources in a new resource group. And it's probably going to deploy it in the wrong subscription, but that's okay because this is just a demo. So it's going to prompt you, hey, do you want to do this? And yes, I do. So I'm going to say yes. And then it's going to start creating the stuff. And so you can see that here. And then pretty fast, we will actually see a new resource group. And actually, I need to show all of my subscriptions because I'm pretty sure it's going into the wrong subscription. Let's find it here. So you can see I have a lot of subscriptions and a lot of stuff in here. So if we refresh this, we should see a resource group with a random name pop in here. And there it is. So the random name generator by Terraform is it creates a pet name, so it uses like a random animal name, and it gives like the name of the pet. But you can see it's creating this in this account. And remember from my slides, I said always specify the subscription that you want to use. I should have followed my own advice. I didn't do that, so now it's deploying this in the subscription I didn't want it to deploy in. But it's actually done. So that actually worked pretty fast. So it created those 26 resources. It went through all the code. You could see it while it was doing it. It created those and it's done. And here are all of the resources. So I created a bunch of, networking for me, created a virtual network, some UDRs, public IP addresses. So that was pretty fast, right? So now if I do a Terraform destroy, remember, don't do this in production ever. Just stay away from this. It's basically going to tell me what it's going to destroy. So you can see that here. You can see all the minuses instead of pluses. And if this was a change, I think it would show like a / mark. But it prompts me to do this. Now, I do have a friend, an MVP, who another MVP who actually was using Terraform space destroy space dash like no confirm or something like that. So he wasn't confirming, wasn't being prompted to destroy, and he actually blew away one of his demo environments where he was actually using critical stuff. So this is actually going to go through and delete all the stuff that it just created, including the resource group. Now let's go over here. Okay, thank goodness this came back. So let's just run this because this actually takes a while, and I'll take you back into the code and show you what it's actually doing. So we're just going to do a Terraform apply here, and this will actually deploy our AKS cluster. Now, deploying AKS clusters takes a little while, so I actually intended to kick this off right away. That way we could let it, run for a while and then, come back and look at the AKS cluster. But so this is going to run, and this is going to do some different stuff, right? So I'm actually using output in this AKS script, and I'll show you what that looks like. And you can see I don't have any AKS clusters in this. Oh, you know what? I got to kill that operation because I need to specify my subscription. because if it deploys in the wrong subscription, then it is going to fail because I don't have enough money in that subscription. All right, so it's set to the right subscription now. So we'll just run this again and it will go to the right subscription. So that's what I mean by setting the right subscription. And what I used there was just Azure CLI commands to do that. And so the beauty of Cloud Shell again is everything I need is just preloaded. All right, so that's going through and that's creating that. We'll come back to that in a little while, and we'll actually jump back here. So this destroyed all of the stuff that I just created, right? So if I refresh this, that resource group is gone. All right, so now you can see I have a new resource group, and this is where it's creating the AKS cluster. So we go in here, there's not much in there yet, but we'll see log analytics populate in there, and we'll see our AKS cluster. Now we're 3 minutes over. Do I need to stop, or can I finish out the demo and can we go over a little bit? Or do I need to like stop right now? Just give me a heads up. If I can keep going, I'll keep going. All right, I'm gonna keep going. Okay, all right, I'm gonna keep going here. So back to the code, the AKS code. So this is our AKS cluster. So we're doing a bunch of things here, configuring what we need for our AKS cluster. We're also adding on the log analytics that we're going to deploy for our AKS cluster. And so that'll run. And that'll run. And then down here in the output, actually, you know what? This is real world, real-time troubleshooting here. So this is actually great. We're going to jump back to Cloud Shell. I received an error. So I received an error because there's a conflict with my log analytics name. So it's telling me that my log analytics name is not unique. The reason why is because if we go back here and we just go to resource groups. So I have 2 resource groups with the same name, but they're on different subscriptions, right? And in my account 0, I have the log analytics already there. And so actually account 1, the log analytics is already there. And so it doesn't like that it has that name already being used. So in order to fix this, what I need to actually do, and I'm actually going to do this in Terraform, and I'm doing stuff on the fly here. So you're seeing some real time like troubleshooting. So if this fails, it just fails. But so what I need to do here is go back to the wrong subscription, the unintended subscription, and then I need to actually run a Terraform destroy, and it's going to remove that resource group, and it's going to remove that log analytics. And then I'll be able to reset back to the proper subscription and rerun Terraform apply, and it'll run and I won't get an error. So now it should be destroying this resource group, and it should be destroying that resource group and the name for that resource group. I mean, the log analytics that's in that resource group. So if we look at this, it's going through, it says, hey, I'm still destroying, I'm still doing my thing. And that takes a little while. But eventually, and let's just actually do this so we can scope this down. So eventually it's gonna get rid of this, and let's see if it already killed the log analytics. So waiting for Azure to update here. There it is. The log analytics is gone already. So that was cool. Let's actually get rid of that Cloud Shell window. So my log analytics is gone. So the next thing that it's going to destroy is the actual resource group. But now what I could do is I can actually stop this, right? In the interest of time, I'm going to reset the subscription that I'm in, the context for the subscription that I'm in, back to the intended subscription. And now I'm going to clear the screen and I'm just going to run a Terraform apply. All right. And this time when it runs through, I shouldn't receive an error because there won't be a conflict with the log analytics name. So the log analytics is a service where you have to have a unique identifier for the name because it's global. So if you have that same name in use on other subscriptions, you can't reuse it, right? So other services that are like that in Azure are like Azure Storage. You got to have unique names, otherwise you're going to run into issues. All right, back to the code while we're waiting for Terraform to go ahead and deploy is the output. So remember in the presentation, we talked about the output and being able to use that. So what I'm doing here is my Kubernetes cluster is created and I'm outputting values from the Kubernetes cluster that I need to use because in the code, I'm going to actually connect to that Kubernetes cluster and I'm actually going to deploy a pod, which is, if you're new to Kubernetes, is a container or containers. I'm going to deploy a container to my Kubernetes cluster just to make sure it actually works. Right, so in the output here, I'm outputting things like the client key, client certificate, cluster CA certificate, username, password, my kube config, and the host, because I need those things to connect to the host. Now notice like here and here, this is a resource. In my output, I don't have a resource. If I scroll up here to the log analytics, I have resources. Same thing with the resource group. What I'm trying to show is these resources are all using the Azure provider. Okay. Now, if I go down here, notice I have provider. And then down here, I have resource. So what happened here is I had to pull in a different provider because that provider, this provider is going to use Kubernetes instead of the Azure provider, right? And what I'm doing here is I'm specifying the host and different things that I need to connect to the actual Kubernetes cluster. And then here, again, this is using the Kubernetes provider to actually create the pod. And I'm just deploying just a simple Nginx pod to the Kubernetes cluster. So that's the code. This failed again. We can give it one more shot. So I'm going to do something that you typically shouldn't ever do. And what I'm going to do is actually use the portal and I'm going to delete the resource group. And actually, it's gone. Let's look at the error message here. Oh, so something else is using this. So one of the ways I can actually fix this is to remove the Terraform state. If I do that, what will happen is it will generate a new name. So if I do another init, it'll actually create a new state for me here after I run the Terraform plan. And one quick cheat code is actually, you can skip the plan and you could just go straight to apply. And it will actually run through the plan because it's going to prompt you with everything that it's going to do. So it'll give you that anyway. I still recommend, in production that you're running the Terraform plan just to go through it, go through the steps and make sure you're covered. Hey, while we're waiting for this to run, why don't we open it up for some questions, and then hopefully after the questions are done, we can this will be done and I'll show you that quick, and then we'll end the session because I know we're over time. So were there any questions?
Steve?
Yeah.
Okay, there are some questions. I don't know if they are going to ask. You want them to ask live or they should type it?
Why don't we have them type them, just so we don't have audio issues, and then I'll go ahead and answer.
Okay.
So yeah, if anyone has any questions, go ahead and type them in the chat while we're waiting for this code to run. And thanks everyone for sticking around. I see that we still have 20 people. That's awesome. Thanks for sticking around, even though that we went over here a little bit on this. So do we have any questions around, Terraform or Azure or anything? I see that Ronald said, don't forget to delete AKS. Yes, indeed. It's an expensive service for sure. What are the advantages of Terraform over ARM? That is a great question. So some of the advantages is that Terraform is very easy to read from a code perspective. It's very easy to get started with it in regards to the syntax and learning how to write the code. ARM is JSON, so it can be a little harder to, understand the JSON code, read it, write it, work with it. And so a lot of people prefer Terraform because of that reason. Other advantages are just, having the phases of being able to do the Terraform plan to see what's going to happen before you do it. Now, I know with ARM, they have a what if that you can run now. I've seen it, and this is my personal opinion. I still like the Terraform plan because it lays it out really nice. Also with Terraform, there's another command that you can run where it will actually generate an image for you with the resources it's going to create or are already there, and it will put the actual dependencies on that image as well, so that you could see those dependencies, and you could take that and put that in your documentation. So those are a couple of advantages over ARM. Also, ARM is just for Azure, right? So if you're using AWS, if you're using GCP, you can use Terraform. And when you have teams of people that are already educated on Terraform, it's a lot easier to go and start using GCP or other cloud providers and not having to go learn cloud formation templates, right? If you're going to work with AWS, that's their native automation and is equivalent to ARM. So there's always that. There's another question in here. Okay, let's take that question. is there a Microsoft exam we could take for this technology? For the actual Terraform? There is not a Microsoft exam for the Terraform technology, but there is a Terraform certification that you can get for Terraform. So there's a certification for that, and it's it's very similar to it's very similar to like your other exams that you would be used to. And let me actually pull that up and get you a link for that question. All right. We have a couple more. Oh, thanks for posting that link in there, Ronald. Thank you. So yeah, there's a Terraform certification that you can get. So it's not from Microsoft, but it's actually from Terraform. Let's see. There was another question there. Is Terraform free like ARM? Terraform is free. So you can start using Terraform today. There's no cost for it. You can just download it and start using it. If you want to use some of the enterprise level features of Terraform, you have to pay for those. So, but yeah, Terraform itself is actually open source. Where can I locate the ARM templates? So ARM templates, your quick start templates. So actually, that's a great question too. For ARM templates, a great place to get started is right here. This is for Joshua. You can use that to get started with the ARM templates. So let me pause the questions for a second and let's jump back into the demo. We'll show this quickly and then we'll wrap it up. So if we look at our Terraform here, you can see that it finished. It added 6 resources and it gave outputs of the certificates and stuff, right, that were needed to actually run or actually log into the Kubernetes cluster. So now we have our Kubernetes cluster deployed, and also notice it gave it a different name. The resource group was a different name. So that's what I did when I deleted the state file and I redeployed it. So here's our Kubernetes cluster. And one of the great things that Microsoft started to do is bring in a GUI into here so you could start to work with Kubernetes and see stuff right from the portal. So we go into workloads and we go into pods. And if we go into pods, we go down here, we can see the Nginx pod that I deployed, right? So my code worked. Here's my Nginx pod that's running. So pretty awesome, right? I did that all from code. I didn't do anything from the GUI. So really great stuff. So if we go here, I'm going to show you guys a trick when you're getting started with Kubernetes. So let's say we want to connect to our Kubernetes cluster, right? So if I run kubectl get pods, this is going to fail, right? Because I'm not connected to my Kubernetes cluster. So I need to connect to that. So if we go to the overview tab of or screen of our Kubernetes, our AKS cluster, we click on connect. Microsoft actually gives you the commands to go ahead and connect to that. So, oops. So we can actually run these really quick just to connect to our cluster. And this will actually connect me to it. And then what I can do from there, so now I'm connected. Now I can run my kubectl command. So I can do kubectl get pods, and this will return my Nginx pod. Just the same information that I can get from the Azure portal now, which is pretty cool. So now I have that. You can see my Nginx pod is running. I could see the services. So I want to see if this is published externally. It's not. Right. So the only thing I have published as far as a service is my cluster IP. So this Nginx pod is running on my Kubernetes cluster, but I can't access that from the outside world. Right. So, I'm not going to go there because we could spend a whole nother hour just talking about Kubernetes. and how to work with it. But you could see, like, I could see the namespaces and different things, and I could work with my Kubernetes cluster. Now, the last thing that I actually want to show you in here is I want to go to the resource group because I want to show you all the stuff it deployed. So here's my log analytics workspace, and here's my container insights. So again, I deployed that through the code, right? So pretty cool that I was able to do all that through the code. The other thing that I want to show you quickly here with Kubernetes, or actually AKS, is every time you deploy an AKS cluster, since it's a managed service, Microsoft creates this MC resource group where it's deploying all of the things, well, not all of the things, but many of the things that are needed to support your Kubernetes cluster or your AKS. So here you could see this is the managed identity that I specified in my Terraform code, right? And here's my VNet that my AKS cluster lives on. Here's a load balancer. So anyways, all of this stuff is deployed. I did everything through code. I didn't do anything through the GUI, and that's the power of Terraform. So now I'm going to stop sharing my screen since we're done with the demo. We're like 23 minutes over. Apologies for that, but this is like real world IT, and we'll jump back into some quick questions, and then we'll drop off the session. So let's see here. Questions. So I shared the ARM templates. Last question here, and then we'll wrap, is from Richard. And when dealing with the Azure marketplace, what do you recommend, Terraform or ARM? That is a great question. When I've worked with the Azure marketplace, to be honest with you, I've used PowerShell. There is some syntax in PowerShell where it makes it easy to accept the agreements from the marketplace. So one of the things you'll run into when you're trying to code and pull things from the marketplace, when you're working with ARM templates, I actually haven't found an easy way to accept the agreement that you have to accept, right? So when you're deploying something from the marketplace through the portal, like through the GUI, you have to accept that agreement before you deploy it. Well, you have to do the same thing in code. And so it doesn't work very well in ARM templates. So what I've done is actually coded that out, accepting that agreement in PowerShell, and then deploy it from there. I've never actually deployed something from the marketplace in Terraform. I've had some colleagues do it, and it sounded like it was a pain in the butt. So yeah, just a quick answer to your question. All right, so that wraps up the demo, the presentation. I hope this was useful. I really appreciate everyone sticking around. There's still 19 people on the meeting. That is amazing. Shout out and love to my people of Ghana. This is awesome. Hopefully sometime in the future when COVID's gone, I can come to Africa and meet many of you in person and do another presentation. So thanks to the team behind the user group for having me on this. And yeah, was there anything else, Abu?
Yes. Really, so much. Everybody's happy here. On Twitter, and thank you.
Yes. Thank you, everyone. All right. All right, you guys have a good weekend, and yeah, hope to see you in person sometime in the near future. Thanks, everyone.
Thank you, Steven.
Bye.
Roland. Roland, is it? Roland, are you online?
Yeah, I am.
Oh, how are you?
I'm good, and you? Let me just put my.
Yeah,
Cameron.
Thank you so much. I can see you as very, very active. Thank you so much. You really contributed there.
No problem. I'll join the next one as well.
Yeah, you have to get ready so that you do some presentation for us.
Okay, no problem. You just let me know
okay.
when it is, and I'll share with the group.
Okay, that's fine.
Thank you so much, Ronald. Thank you so much.
No problem. Nice to meet everyone.
So thank you, everyone. You definitely, we are going to share the recording. You will get the part of the session if you didn't attend.
Okay, thank you too. Nice weekend.
Thank you, guys.
Okay, guys, thank you so much for making time to join this session. We especially thank the speakers for the great content they share with us. Forward to have more of this session, more of this engaging session where we try to learn new technology. So we will make the recording available. I'll personally send it to you via email, but it will be, you will send it here in the chat in case some of you want to pick it. And if you are not part of our community, we will leave a message. We will leave our the registration link on Meetup and our various social media platforms, so you can easily join us and you have access to this document more frequently and in an efficient way. Thank you so much, and I bring this meeting to an end. Have a nice weekend, all of you. Bye-bye.
Bye. Thank you too.
Bye.
Thank you so much. Thank you so much. Thank you so much.